Good evening, madam.
Good evening, sir. Good evening.
Good evening, sir.
Good evening, madam.
Good evening, sir.
Good evening. Resource person has come, madam.
Sir, resource person is already joined, sir. They are in the
You
meeting.
call principal, man. You call Ashwin. You call principal.
Yes, sir. Yes, sir. Already I invited.
He is joining, huh?
Yes, sir. Yes, sir. Sorry. 1 minute, sir.
Okay. Madam, you can start. Principal has joined.
Okay, sir. Okay, sir. Sure.
Good evening, everyone.
Good evening, sir.
Good evening, sir. Good evening, sir.
Future belongs to those who prepare for it today. Malcolm X. A very warm welcome to all the distinguished speakers, esteemed academicians, and enthusiastic participants. It is both an honor and a privilege to inaugurate this highly anticipated faculty development program on future ready AI, emerging technologies, and their societal transformations. Organized under the aegis of the Department of Information Science and Engineering, AMC Engineering College, this meticulously curated FDP underscores an unwavering commitment to staying at the vanguard of artificial intelligence and its transformative potential. At the very outset, I would like to express my profound gratitude to our chief patrons, Dr. K.R. Paramahamsa, Chairman, Mrs. Geeta Paramahamsa, Vice Chairperson, Mrs. Monica Kalluri, Vice President, Mr. Rahul Kalluri, Executive Vice President, and Dr. Mohan Babu GN, Director of AMC Engineering College, for their unwavering support and visionary leadership that continue to propel this institution towards academic and technological excellence. A special acknowledgement to our convener, Dr. K. Kumar, Principal of AMC Engineering College, whose guidance and stewardship has been pivotal in orchestrating this enlightening event. Furthermore, my sincere appreciation to Dr. Ashwin M., the FDP coordinator, and Dr. R. Senkamanavalli, the coordinator, for their relentless efforts in curating this intellectually stimulating program. Over the next 6 days, from Feb 3rd to Feb 8, 2025, we shall embark on an intellectually invigorating odyssey, delving into the multifaceted realms of AI, its avant-garde advancements, and its profound ramifications on society. This FDP will not only merely be a discourse on technological progress, but also a deep contemplation of AI's ethical paradigms, socio-economic repercussions, and its boundless potential to redefine human civilization. We are immensely privileged to be graced by erudite scholars and industry stalwarts who will illuminate our path with their invaluable insights. I urge each of you to engage proactively, foster interdisciplinary dialogues, and harness this platform to cultivate pioneering perspectives that will shape the future of AI-driven innovation. With that, I extend my warmest welcome to all of you. Let us seize this opportunity to learn, collaborate, and contribute towards a future that is not just technologically proficient, but also ethically and socially conscientious. Thank you, and wishing you all an intellectual enriching experience. Lead us from darkness to light, from ignorance to wisdom, and from fear to knowledge. As we embark on this faculty development program on future ready AI, emerging technologies, and their societal transformations, let us take a moment to invoke the spirit of knowledge, enlightenment, and progress through the symbolic virtual lamp lighting ceremony.
आरोग्यं धनसम्पदः शुभं कुरुत्वं कल्याणम् आरोग्यं धनसम्पदः शत्रुबुद्धिविनाशाय विनाशाय दीपज्योतिर्नमोस्तुते दीपज्योतिर्नमोस्तुते शुभं कुरुत्वं कल्याणम् आरोग्यं धनसम्पदः शुभं कुरुत्वं कल्याणम् आरोग्यं धनसम्पदः.
To set the tone for this enlightening session, it is my honor to invite a distinguished academic leader who has been an inspiration to many, Dr. R. Amata, Head of Department of Information Science and Engineering, AMC Engineering College. With her immense expertise, dedication to academic excellence, and unwavering support for faculty development, she has been instrumental in shaping the department's success. Without further ado, I invite Dr. R. Amata to deliver the welcome address and officially commence today's proceedings.
Thank you, Priyanka. Good evening to everyone. I am delighted to welcome you all to the ATAL-sponsored online faculty development program titled Future Ready AI, Emerging Technologies and Their Societal Transformation, organized by Department of Information Science and Engineering, AMC Engineering College, Bangalore. First, I would like to welcome our Honorable Principal, Dr. Kumar K., whose leadership inspires us all. Welcome you, sir. I would also like to welcome our respected academic advisor, Dr. R. Nagaraja, whose support is invaluable to our students. Welcome you, sir. I welcome all the HODs of various departments and faculty members in various institutions. As we all know, artificial intelligence is no longer a concept of distant future. It is reshaping the way we live, work, and interact with the world around us. This FDP is designed to provide a platform for knowledge sharing, collaboration, where participants from diverse backgrounds, be it academia, research, or industry, can come together and explore how AI can shape the future. The sessions we have scheduled will cover wide range of topics from the fundamentals of AI to its ethical considerations, real-world applications, and transformative potential in modern industries. I encourage all of you to actively engage in these discussions, share your thoughts, and make the most of this opportunity to learn from our distinguished speakers and fellow participants. Once again, welcome to this enriching journey to the world of AI. I hope this FTP will not only enhance your knowledge, but also inspire you to explore new avenues in AI and its applications. Thank you once again.
I extend my heartfelt gratitude to Dr. R. Amata, Head of Department of ISC, AMC Engineering College, for graciously welcoming the gathering at today's Faculty Development Program. Your warm words and insightful thoughts set the perfect tone for the event, and we truly appreciate your support and encouragement, ma'am. Thank you for your leadership and for inspiring all of us. It's a moment of great honor and privilege to have with us a distinguished academician and a visionary leader, Dr. K. Kumar, today's chief guest and principal of AMC Engineering College. His unwavering commitment to academic excellence and faculty development has been instrumental in fostering a culture of learning and innovation. As we commence this faculty development program, I take immense pleasure in inviting Dr. K. Kumar to deliver the inaugural address and share his insights with us.
Thank you, madam. Good evening to everybody. Our Honorable Academic Advisor, Dr. Nagaraj sir, and today's speakers. My sincere gratitude to the organizers of this future-based AI workshops, the department heads and all the team members, and also the participants logging in at this busy schedule. And then I see 78 plus viewers being there with us. So I thank all of you for the interest, and special thanks to our speakers, today's speakers, who have really soiled their hands in understanding the current state of the art requirement and also putting forth their views and subjecting it for the discussion. As you all know, that today AI is getting into even the kitchen and the bathroom also. So there's no space. AI is now becoming omnipotent. It is next future's god basically. So whatever be the case, we being the academicians are the torch bearers to the society. So and I really thank all of you for the interest which has been shown to make this subject more simplified. And not only that, you are the torch bearers, and you have to get more clarity on the applications front. And finally, it has to reach the end users for the innovations in the heading towards the nation building activity. So with all this, I congratulate the team and also the speakers of today. I'm really interested to know their findings and their applications, so that it is going to make us more viable and more clearer. Thank you all once again. Thank you.
I extend my heartfelt gratitude to Dr. K. Kumar, Principal of AMC Engineering College, for his inspiring and insightful speech at Faculty Development Program. Your words of encouragement and wisdom have truly motivated us, and we deeply appreciate your support and leadership in fostering a culture of learning and growth. It is our privilege to have with us a remarkable academic leader, Dr. R. Nagaraja, Academic Advisor of AMC Engineering College. His dedication to academic excellence and faculty empowerment has always been a guiding force for us. As we embark on this faculty development program, I now invite Dr. R. Nagaraja, Academic Advisor, to share a few words about the significance of this FDP and its impact on learning and teaching. Sir, we are eager to hear your thoughts. Please join with me in welcoming him.
Thank you, madam. Our beloved principal, Dr. K. Kumar, HOD of ISA department, Dr. Amuta, and his team, heads of various departments, faculty, and the participants of today's the FDB program. Indeed, as uh, told by our principal, AI is entering everywhere, and it is continuing to grow. And we have seen recently the new AI model developed by China has in fact affected the economy of USA. Okay, they were able to produce a very cheap AI model, that is DeepSeek, okay, which has reduced the stocks of NVDA drastically. Trillions of dollars of loss has happened to the USA. Okay, there's a lot of work going on AI, artificial intelligence, and its applications. And it is the time our faculty get enriched by these AI concepts and their applications. And I believe that if one faculty has the knowledge, then it is equivalent to training 100 students, because a teacher in turn will disseminate the knowledge to hundreds of students. So I always believe in training the faculty so that they become a good resource people, and will be able to produce the engineers with a good knowledge of artificial intelligence, so that they can become productive and will get good uh, placements in future. So on these lines, the training on AI is a very important concept. I congratulate ISC department HOD and their team for having organized such a wonderful workshop with so many applications. Okay, I am also interested in attending because of the speakers. Some of the speakers are very good. On this occasion, I thank all the speakers who have we have accepted the invitations and be a part of this workshop to give you a few examples that AI now has entered into many categories of applications. Few recent applications are generative AI model, creative platforms, workplace collaboration, AI in email management, AI for decision making. Like that, many new areas have been selected by researchers, and their knowledge are very important for our students. And these applications illustrate the transformative impact of AI in making tasks more efficient, enhancing creative, and supporting decision making across various domains. A day has come where each and every student should know about what is AI and how to apply this AI concept for various domains. Okay, and I wish all the best to the team as well as the participants. Okay, once again, congratulations and all the best. Thank you.
Thank you so much, sir. I sincerely thank Dr. R. Nagaraja, Academic Advisor of AMC Engineering College, for delivering an insightful and inspiring speech at today's Faculty Development Program. Your words of wisdom and valuable perspectives have enriched the session and motivated all of us. We truly appreciate your time, guidance, and unwavering support. Thank you once again, sir.
Thank
It
you.
gives me great pleasure to invite a dedicated academician and a driving force behind this faculty development program, Dr. M. Ashwin, Professor of ISC Department and Coordinator of ATAL FTP. His commitment and efforts have played a crucial role in organizing this enriching program. I now invite Dr. M. Ashwin to share a few words about this online FTP, its objectives, and its impact. Over to you, sir.
A very good evening to everyone. It's my pleasure to welcome you all to the inaugural session of this 6 days ATAL sponsored online faculty development program organized by Department of Information Science and Engineering, AMC Engineering College. The ATAL FTP is an excellent opportunity for us as educators and professionals to enhance our knowledge and stay at the forefront of emerging technologies. This program will help us better understand AI potential, its current trends, and how it can be applied effectively in both academic and industry settings. The sessions are handled by industry and academic experts from across the country and overseas, each bringing their unique insights and experiences on various aspects of artificial intelligence. Let me give you a brief overview of these sessions. Today, session 1, generative AI with large language models, practical insights and future scope will be handled by academic expert Dr. Vijayalakshmi P. from Presidency University, Bangalore. Then session 2, future trends for societal consequence of emerging AI technologies will be handled by academic expert Dr. Soundarajan S. from Amrita Vishwa Vidyapeetham, Chennai campus. Then day 2, session 3, ethical AI challenges in technology implementation will be handled by academic expert Dr. E. Sukanya from SSN College of Engineering, Chennai. Then session 4, application in data analytics and decision making will be handled by industry expert Mr. Subhash Nair from Bosch, Bangalore. Then day 3, session 5, AI application in autonomous system will be handled by the industry expert Mr. Gopalakrishnan is from Philips Private Limited, Bangalore. Session 6, AI fundamentals, building blocks for the future will be handled by industry expert Dr. Selvaraj Keshavan from DXC Technology, Bangalore. And day 4, session 7, AI application in healthcare will be handled by academic expert Dr. A. Murugan from SRM Institute of Science and Technology, Chennai. And session 8, AI Innovative Strategies for Modern Applications, will be handled by academic expert Dr. Vinay M. from Christ University, Bangalore. And day 5, session 9, Emerging AI Tools and Technologies, will be handled by academic expert Professor Pankaj Kumar from Acharya Institute of Technology, Bangalore. Session 10, AI Transformation for Education and Industry, will be handled by industry expert Mr. Vijay Shankar Kanakarajan from Intellex, Bangalore. Then day 6, session 11, Gaussian splitting model basics, will be handled by industry expert Mr. Ajay Devanandan from OpenStream AI, Bangalore. Session 12, Artificial Intelligence in Business Analytics, will be handled by academic expert Dr. N. Girija Narasimhan from University of Applied Science and Technology, Muscat. Finally, the session 13, High Performance Computing with Digital Twins, will be handled by academic expert Dr. Amudavel Javel from De Montfort University from United Kingdom. So we are very fortunate to have such a distinguished panel of speakers for each of these sessions, and we believe that every session will add significant value to your understanding of AI and its applications. I encourage all of you to actively engage in the discussions, ask questions, and make the most of this opportunity to expand your knowledge. Thank you once again for joining this FTP. Thank you all.
Priyanka,
Priyanka,
unmute.
your mic is muted.
Yeah. I extend my sincere gratitude to Dr. M. Ashwin, Professor of ISE, AMC Engineering College, and Coordinator of FTP, for his wonderful speech and for providing a comprehensive introduction to the Faculty Development Program. Your insights and guidance have set the perfect foundation for the sessions ahead, and we truly appreciate your efforts in making this event a grand success. As we draw the curtains on this intellectually stimulating and enriching faculty development program, it is only fitting that we take a moment to acknowledge the invaluable contributions to those who made this event a resounding success. To extend our heartfelt gratitude, I now have the privilege of inviting Dr. R. Senkamanavalli, esteemed professor of ISC Department and co-coordinator of the ATAL FTP, to deliver the vote of thanks.
A very good evening to one and all. On behalf of the entire organizing committee, I would like to express my heartfelt gratitude to all of you for your valuable participation in this ATAL FTP. First and foremost, I extend my deepest gratitude to Dr. K.R. Paramahamsa, our esteemed chairman, Mrs. Geeta Paramahamsa, vice chairman, Mrs. Monica Kalluri, vice president, and Mr. Rahul Kalluri, executive vice president of AMC Group of Institution, for their constant encouragement. A special thanks to Dr. Mohan Babu, GM, Director, AMC Group of Institution. My heartfelt thanks to Dr. K. Kumar, Principal, AMC Engineering College. I also extend my thanks to Dr. G. Shivakumar, Vice Principal of AMC Engineering College. I wholeheartedly thank Dr. R. Nagaraja, Academic Advisor, for their unwavering and guidance and support. I am grateful to Dr. R. Amuta, Head of the Department, Information Science and Engineering, for her invaluable support. Our sincere appreciation to all the distinguished speakers who will enrich our knowledge through this FDP with their insights and expertise. I also extend my heartfelt thanks to the organizing team, including the dedicated teaching and non-teaching staffs of AMC Engineering College. Finally, a big thanks to all the participants for your enthusiastic involvement and participation. Thank you, one and all. Wishing you continued success and growth. Have a great evening. Thank you once again.
I sincerely thank Dr. Senkamnavalli R., Professor of ISC AMC Engineering College and co-coordinator of the FTP, for delivering the vote of thanks. Your thoughtful words beautifully acknowledge the efforts of everyone involved and brought the session to a grateful conclusion. We truly appreciate your support and contribution to the success of this program.
Thank you, one and all. So once the resource person is joined, we'll start the session. So we will wait for a few minutes. Thank you, sir, for joining the session. Principal sir, Nagraj sir, HOD ma'am, and everyone.
Madam, the resource person is already joined.
Okay.
Just will confirm with Madam once. We'll start the session, Madam.
Okay, sir.
Hello, am I audible?
Yes, ma'am.
Yes, yes, Madam, you're audible.
Good evening to one and all. I am here present, sir. We can start the session.
Okay. Good evening once again. Now I request Professor Priyanka to introduce our resource person, Dr. Vijayalakshmi P, to the participants.
Thank you, ma'am. Good evening, everyone. It is my absolute pleasure to introduce our distinguished speaker for today's faculty development program, Dr. Vijay Lakshmi P. Dr. Vijay Lakshmi P is a professor at the School of Computer Science and Engineering and Information Sciences at Presidency University, Bangalore. She holds a PhD in computer science from Karunya University, Coimbatore, and brings with her an impressive 23 years of teaching experience. A dedicated academician and researcher, Dr. Vijay Lakshmi P has made significant contribution in the areas of soft computing, ad hoc routing with interoperability, machine learning, deep learning, and wireless mobility management. Her expertise has been recognized through numerous research publications in reputed journals and conference proceedings. Beyond her research, she has played a pivotal role in mentoring scholars, delivering expert talks on state of the art technologies, and securing funding for workshops and seminars. She holds editorial positions in prestigious journals such as International Journal of Electronic Signals and Systems and the American Journal of Neural Networks and Applications. Today, as she shares her valuable insights with us, I am certain that we will gain a deeper understanding which will greatly enrich our academic and research perspectives. Without further ado, I let us extend a warm virtual welcome to Dr. Vijay Lakshmi P.
Yeah, I would like to thank Professor Priyanka for having given me a very good introduction about me, and I would like to take this opportunity in thanking the whole management team of AMC Engineering College and all its administrators for having given me this opportunity, and also the organizing team of this ATAL FTP. Would like to thank the opportunity and a very warm good evening to all the participants here for taking you all to this evening session. Hope I could start the section so that I could mute, turn off my camera, and I'll go for sharing my slides. So, may I take a confirmation that is my screen is getting shared?
No, ma'am, not yet.
It's not yet getting shared. 1 minute. I get an option.
Yes, ma'am. Now we can see your screen.
Yeah, it is getting shared. 1
Yeah.
minute. Is it visible, ma'am?
Yes, ma'am, it is visible, but I don't see it still PPT being presented, ma'am.
Is the PPTs, can you see the PPT slides?
No, not yet. We have a screen of any frequently visited. We have another window being projected.
1 minute, ma'am. I'll just get back.
Yeah.
This is a Mac system that doesn't, sometimes it. Is it now possible, ma'am? Is this
Yes,
like,
now we can see. Yes, yes, ma'am. You can go on for the slideshow. Yes, we can see, ma'am. Perfect.
yeah,
Perfect.
all right. Thank you so much.
Thank you.
I would like to give a general lecture on generative AI with large language models. That mean a practical insights in the future scope in the 6 days FTP program. So I would like to take to, having a complete vision about what is called as generative AI. As we all know about what is an artificial intelligence is all about, and how this generative AI works with the large language models, what we call it now as LLMs, and how this will give us the future scope, a nearby future scope that it could lead us into our everyday life. So to begin with, we have something called as supervised learning and unsupervised learning, as this could be the introductory part of your machine learning. So machine learning is going to be a subset of your artificial intelligence, where machine can learn on its own without any human interventions, and it can predict some output. And the outputs are compared with the actual data, or what the actual output we expect, than what the machine has predicted some output. So this is what a supervised learning is all about. So we give some data as an input X, and we are going to train the model with that huge amount of data. And the model is going to be tested with some amount of data, and it is going to predict what this input X could be of. Say, for example, if you give an image of a dog and you want the answer to be as a predicted output to be as, yes, this is an image of a dog and this is not a cat. So in this case, your expected output or your predicted output is compared with your actual output. And if there are any errors, and if there are any loss, and if your accuracy is going down, so normally we go and update the model what we have designed and model what we have been trained. We update the model so that for the next input set of X data, might be X1, X2, or other data, your model will be able to predict it. So we keep on repeating. If error comes, again we train the model, and if the error comes again we train a model. So we take n number of epochs so that the expected output, it reaches almost the actual output what we require. So this is what called to be as a supervised learning. So we give a label to data and we train the model what we expect the model to be of. So in unsupervised learning, what happens is that we have a model with unstructured data. The model, the data is not being labeled. In that way, how your model is going to get trained, how it's going to learn the data, and how it is going to predict their output. This is what we have learned in our machine learning. Now, I'm directly taking you to what is called a generative AI. So we already have the model being built. See, if you want to predict anything in your near future, like you can predict a disease of a crop, you can predict a disease of a human being, you can predict whether it will be raining tomorrow, whether I'll go to college, whether the professor will be present for the college tomorrow or not, whatever may be, whatever the problem statement, the real world applications be of, we are able to predict, we are able to train the model with huge set of data. I can give 100 years of data to play around. See, a batsman Sachin Tendulkar is playing, he's batting, and the renowned Pakistani bowler is bowling. I can predict whether Sachin will be now giving a 6 or 4, or he'll be a wicket. I can predict to that extent by using a reinforcement learning. Then why the hell the generative AI came into existence? What is something new the generative AI is going to come, is going to give us something more is all about. I'm going to talk in today's session. See, we have a training code, we have a labeled data, and we build a model. So all your ML, DL, all your neural networks is going to predict or classify or cluster or group the data. Yes, it belongs to this or not, or whatnot. Now, we have a generated AI model where the model can learn not from the data, what we are giving for him to train. The model learns the patterns of the data. It learns the patterns, and it can make a what to say, it can make a more conceptual senses to that data, and it can automatically predict what could be the next and what not could be the next. And moreover, it could give you the suggestions as well. Suppose you don't fall into this category, either either this is a dog or a cat. Your model can predict either it is a cat or a not. So only it can classify and it can cluster. When you go to a generative AI model, it can give the answer, plus it can give you the possible list of suggestions. So that is what the generative language models like your GPT, given by your OpenAI, Gemini by Google, Lambda by Google. So are all will learn the patterns. So are all the language models being defined where they can learn the pattern, and they can directly answer your questions as well. See, you just think about how Alexa works. So how your Siri works, you can ask anything to it. It can reply you back in an audio. It can reply you back in a text format. Immediately it can give out. But there are some limitations. So this generative AI models, I call these are generative AI predefined models. Every model is ready-madely available. It's just like that. You can go purchase a model and you can use for your own application and throw your model when it is not required for you. So you take it for, you hire a model for, or you rent a model for some time, you use it, and you can disclose the model if you don't want that to get used. So this is how the open AI has come now. This is how your GPTs works now. So this generative AI, see, I'm asking a prompt. Can you see to my right side of the image? I have given here a prompt where it will create an image of a dog for me. So you have like thousands of varieties or lakhs and lakhs of varieties of dogs are there in the whole world. So just to give a prompt, prompt is nothing but an user input in a text format, image format, audio format, or video format, or whatever can be of. You just give and create an, I'm just giving a prompt saying create an image of a dog. So it gives the possible images of how a dog look likes. See, if I want to train a machine learning model by giving this set of input of different varieties, different shapes, and different structures of a dog, I need to use lakhs and lakhs of data to get trained. Even though if a new dog breed has come into existence, again I need to train the model, and that model may predict or may not predict, may go in vain. So your generated AI model have a more accuracy compared to that of your neural networks model. This is also a neural network compared to that of your traditional DLML models. It works intelligently. It works better with more accuracy, I could say. So this is a type of an artificial intelligence that creates new content based on what it has been learned from the existing content. So what it has learned, it will create on its own. So this is how a generated AI model works like. See, this model has got built in, now we call this as a transformer model. In your deep learning and machine learning, we have learned about RNN, recurrent. We started learning from perceptron, what is neural network, what is a artificial neural network. Then we came to CNN, then we came to RNN, then we came to LSTM and GRU. So we stopped over there. And later part, we have learned about something called as transformers. That is how the GPTs came into existence in 2020 itself. OpenAI has given the release of GPT version 1.0, and right now we have the GPT version 4.0 mini and 4.5, where our students here have been, we have been teaching the students with this GPT-4, that is open AI models. We have given training to the students here and they have learned about it. So we have a transformer here. So I talk about, no, I'm not talking about LSTM, I'm not talking about GRU. I'm talking about a transformer model which has got a generative technique and a discriminative technique. So generative technique is nothing but which could generate. See, for example, the previous slide, it could generate the images of a dog. That is the work of a generative technique. Please follow my slide or the images onto my right. Take from right to left. The generative technique will actually generate the images. It does this process. You're asking create an image of a dog, so it will generate the images. Then what does a discriminator will do? So discriminator normally will classify whether this image belongs to a dog or a cat or another species of an animal family or not. So the discriminator will check it out with its real-time data, with its actual data, and identifies the loss or the error and rectifies it by using some accuracy techniques, probably could be of. So this is what a transformer does, and this is what your your transformer model will be working. Apart from this, I mean, an employee of a Google has introduced a concept called as an attention mechanism. See, attention mechanism is the one that we normally use in the transformer models. That, say, for example, you're peeping through your BBC News or CNN News for for some of the latest world kicks of today's the very hottest magazine like India Today. So what happens here is that for the past 1 week, which is an article you're been using in that magazine, is always being quoted in attention. That means in double quotes. In India Today, on Jan 30th, this is the article you read, and this is how my customer is more interested in this article, and it's my duty that I need to give you a 10 more articles related to it. So this is how your transformer model, which can learn on its own with the patterns what you have done it. It doesn't learn on the data. It learns on the patterns of each and every user. It remembers it. And then it proclaims that this could be the possible use and this is the, I'm sorry, and this is not the possible page where my own user has not navigated into it. So the next time today at 6:30 p.m. when I go into either a news portal or into a magazine portal, something there, the very recent pattern I have gone through it is popped first. So this is how your generative AI model will works with the concept called as self-attention. So you have to make a note of the very important terms here. I've taught you about what are the LLMs. So the LLMs could be of your GPTs by OpenAI, and another one is Lambda, and another one is like Claude by Anthropic. These are the language models that are given as an input. So those models can learn anything in a different varieties and can give you the outputs. So the LLM models you have to remember, I've talked about transformers and I've talked about what is called here to be as in self-attention in transformer. So this you cannot find it out in an RNN or an LSTM. Even your RNN can predict, say, for example, today it is cloudy, so it is expected to dash. Your RNN can predict to be rainy or so it is expected to rain today. RNN can predict. Suppose if you give an input of a paragraph containing 10 lines, whether your RNN can predict this, your RNN cannot predict because it has a short-term memory. That is why we introduce LSTM. So LSTM, I have 10 paragraphs. Say in the first paragraph, I've written one sentence. I'm settled in France. And in my 10th paragraph, I can say that I'm very fluent in speaking dash. In the 10th paragraph, last line is this. In my first paragraph, first line is I have settled in France. So if this is given as an input, if this text is given as an input, your LSTM can predict what your next word is all about. It can say that you are very fluent in speaking French. Then why not? I'm not using LSTM. I'm not using GRU. Then what's the speciality of this transformers? What's the speciality of GPTs? One very good example of your transformer is your GPT models, isn't it? Then what's something special in GPTs? Everything I can achieve in my LSTMs. Then what's something about this set of transformers over here? So here your generative AI, again, it is a part of your it's a part of your deep learning, I could say that. So it is nothing but a set of algorithms that can generate new content. Always underline the word. It can generate a very new content, the content you want it to be in a text to audio, image, or video. In any data modalities, your what is that? Your model, your Gen AI model can generate very new contents related to it. So this generated content is similar to the content of the algorithm that you are trained on. Suppose if you have trained an image, this is very important. Second point is very important. Whatever you have been trained on, like your model will be able to generate the content on that same. You have trained a model for a very unpeculiar tumor in your brain, which cannot be stimulated even by your MRI scans. So if your model is being trained for predicting that, so that new content prediction can be based only on that image of a brain tumor and not the tumors of, like say for example, the tumors you have it in your hand, in your what's in your legs, or something else that cannot be done into it. So a prominent type of generative model is the large language models. See, for example, I'll tell you what is a large language model. See, if you want to train a machine learning model, you want a huge data set. Am I correct? You want a huge data set. Here, I want to generate a new AI model where it can reproduce new content. So I need a very large language models. So we call them to be as LLMs, that is purely based on large language text, where you can just query it, you can just use a prompt and you can get it done. And moreover, I have used only the transformer. So that is what I have given you. It is a generative pre-trained transformer. We call that to be as to be as GPTs. And the GPTs which is used for only conversation of your text, which is used for only the text purposes, we call that to be as a chat GPTs. So this could be the examples of your LLMs. So you have any doubts still here? If any in this slide, if anything you find, any context you find like Greek and Latin, I'm ready to explain to you. Can I proceed? Can I take a confirmation from the audience? Can I proceed?
I
Yes.
think
Yes. Can I proceed?
yes, ma'am. I think they have replied in the chat box as well as thumbs up. Yeah, I think.
All right. Thank you. Because I can't see the chat.
I understand. That's why. Yeah, you can proceed, ma'am.
Yeah, all right. Thank you.
Yeah, thank you.
See, and one more thing here is that, see, you have what is a Gen AI model when compared to that of your predicted machine learning or your DL model. So the data and the labels are very much important. Suppose if you want to train a model based on ML algorithms or you're based on DL algorithms, they learn the relationship between the data and the label and they will give you the output. Whereas once when you take about a generative AI model, just a prompt or a text like an image or a text or like an audio or video is given as an input, it learns the patterns of those unstructured conversation or a context or a comprehensive context or a phrases or the image patterns, whatever it may be, or an audio text patterns, it will learn those patterns. It will learn the audio pattern, it will learn the video pattern, it will learn the conceptual, conversational chats pattern, and it reproduces a new content. So that new content, we call that to be as the model that generates the new data out of it. So this slide is very important. Your predictive model will, ML model will learn the relationship between the data and the label, whereas in case of your Gen AI model, can learn the patterns in the unstructured data content and can reproduce a new content. And still, this slide can give you still more clarity on what is machine learning output and what is a Gen AI output could be of. See here, when you take any input to any model that we want to depict, maybe your machine learning model, the output could be in numbers. Agree with us? See, and then the output could be in a discrete values, the output could be in a probability, or the output could be in a categorical class variables. Yes, it belongs to this class or not that or that class. So this is how your machine learning output will be, and that is not the generative AI output. Always your generative AI output, the model gives the new content as an output in a natural language processing. It can talk to you as how a human talks. There are some models where you can talk. See, I'll give you an example. This is the programs. One of my student has done a project on this. The last semester when I was handling the same course. So a mini project was done on this. He just talks to a model, a GPT model, saying that I just forgot my son's name. I just forgot my nephew's name. She just settled back when I was 5. She settled in US. I forgot her name. The Gen AI model given by OpenAI just was talking to her like, how old are you when you were playing with your nephew or with your niece, and what are the toys you were using for playing, and what was the occasion that you spent your holidays together. So these are all some of the recollections of the past history, and that made him to really have a big smile on his face, that it could predict not the actual name, at least his or her pet name. So this is how the generative AI model will speak to you like a human. This project was done, and this project was given a a demo, and it got the first place, being guided by our faculty and by me. So this is what it happens. So this is how the student have done a project, and this is how it plays like it talks to you like a human interface. So this is the output of your Gen AI model, not like your ML model. Could be of numbers or discrete values and something like that. So it could give you an output like an image, it could give an output like an audio, it could give an output of video and all the other things. So now coming to, hope you're clear with the concept. So far I have been trying to make you understand about what are the concepts, what is machine learning, what is generative AI, and then I'm talking about LLMs, transformers, and the examples, and comparison of ML with Gen AI, and the output comparisons of your Gen AI with your ML systems and everything. Now I'm going I'm going to take you into the concepts of Gen AI. So I've told you prompt is given as an input. Prompt is nothing but the user query or the user input in the form of text, in the form of audio, in the form of video, etc. Say for example, here I'm giving a prompt saying like, summarize the text of X and generate a poem in the style of X, and give me the list of keywords based on the semantic similarity of X. So these are all the prompt I'm asking the generative AI model. I'm asking the LLMs. So LLMs could be your GPTs, or your LLMs could be your cloud. LLMs could be your Lambda. LLMs could be your MedPalm 2. These are the examples of your LLMs, I could say. So it all the prompt sits on your LLMs, and your LLM will be able to search the correct answer for this set of prompt what the user is asking, and gives the output. What is your first prompt? Summarize the text. It is giving the summarization. You see the output. I'm talking about the picture onto my left side. When I ask here about the summarization is given at the output. The next one, generate a poem. See the prompting, generate a poem. See, it generates and writes a poem for you. Then give me the list of words based on semantic similarities. Might be your synonyms. What is a synonym for liking? So it gives out the very key extraction, the similar synonyms of liking. So that is how it gives you the output. So this is how your prompting your model works in. See how it's going. Say for example, when your prompt is very colloquial, manner, when that is given as an input to a transformer, I've told you GPTs are nothing but the transformers. So transformers will have an encoding and a decoding component. So GPTs are your decoding component. BERT could be an example. So BERT is always an encoder format. That means that 80% encoding it will do and 20% decoding will do. Whereas your GPT is 80% decoding will do and then 20% encoding will be doing it. So that is why it comes to a transformer, could be a BERT or a GPT, whatever may be of. And that is how it sits on your GPT transformer model and it takes the output. What's your input? How is going is your input. And what's your output? I'm doing all right. Thanks for asking. And how about you? So this is the output, like how it takes the input from different LLMs, and then it gives you the output. So this is how it works. So as what I've told you, your generated models, probably your generative language models, will learn about the patterns, what I've told you, and through its training a data. Suppose if you train your data with text, it will predict what type of the text, and it can predict what is your next text and everything. Suppose if you train your model, a generated image model, then what happens? You have many different types of diffusion techniques. Say, for example, Midjourney is there, then DALL-E is there, then you have Cloud is there, Llama is there. These are the different diffusion models that can reproduce the images very, very, very promptly, which could give you a very creative images. You cannot predict these images are generated by the transformers. You can't predict. The images will be more realistic images, and that can really catch your eye catcher. That cannot be the real images, but these images are generated images. So it can really what to say, fake our real data. So this is how so now when I'm coming to the image on to my right side, I'm talking. Suppose when you give image as an input, so like you get a very image resolution can be very more, and some animation can be done onto that image, and that image can be described with a very huge text. Okay, so and everything can be done with that, with these generated models. See, now I'm telling you, Gemini is one of the very good generated model that is being devised by Google. So here the students are also trained with this Gemini tool given by Google also. See, for example, you just see the prompt here. I am making a sandwich with peanut butter and I'm expecting a not the what could be the next word. I'm expecting the decisions, or I'm expecting the whole content related to making a sandwich and peanut butter. what dishes you can make, what are the different types of combinations you can make. This is how your Gemini model will gives the output of a particular text. This you cannot find it out in your RNN or in your LSTM. It cannot generate a new content related to any text. It cannot generate a poem. It cannot generate A.R. Rahman's music. It can stimulate the exact music with the complete rhythm and whatnot, the genres of that music, and reproduce a new content. So that could be the fake music generated by these models, but that could be the real music. We don't need a new composer similar to A.R. Rahman. Our model can generate wonders in that, in this musics. So once if you train the model with all the LLMs, all the all the data related to A.R. Rahman's latest musics, it can reproduce it within no minute, the same music that you can compose it of. So here, with a sandwich and peanut butter, see the suggestions it is giving, like not only sandwich and peanut, a jelly or jam with strawberry, grape, raw, raspberry, apricot, peach, blackberry, blueberry. These all could be your toppings, so that it will add a flavor to your sandwich, and the peanut butter could be off. So this could be the more suggestions where we expect. See, the next part is the meaning of life is. See the suggestions it is giving you. We expect one answer, it is giving you 10 answers to you like. So this could give you the description of how, how volatile your answers could be refined, or it could be precised into a very relevant manners. So this is what your Gemini is again an LLM given produced by Google. So what are the types of generative models? See, ma'am, you've been talking about generative models, GenAI model. What is this model is all about? We have understood the basics of generative models, but what these models could be of? See, there are different types of gen models for different data modalities. See, I would like to make clear with the word called what is a data modality. Excuse me. Data modality is nothing but the different context of your data. Say, for example, you want text to text conversion. You want text to audio conversion. So you want text to video conversion. So this is the different data modalities. So there are some predefined models. Please understand, there are some predefined models already available in the market, given by the Google, given by the OpenAI, given by the Cloud or Anthropic. So these are all the resources. These are all the providers who have already made the model as ready-made. You can go and wear your ready-made jacket or your blazers, and then you can excel in your presentations. So you need not tailor your own jackets, you need not tailor your own or customize your own blazers. All models are available in a ready-made. Take it, rent it, use it, and throw it off. Okay, so you were asked to use it for the number of tokens you wanted to get used, and later you can dispatch it off it to the same provider. So hope you understood now what is the generated types of generated models and what are the data modalities, what I'm going to talk in the next few slides. You have something called text to text. See, I give input of a text. I want to convert into a text. See here, for example, you see the image onto my left side, something called prompting. Summarize the text X. I'm giving X as an input and I want to summarize it. Write a poem. So the input is generate a poem and the output is I'm going to write a poem. Okay. So that is how the generated model will look like. The models that generate text from the input text, like your conversational agent. So these are all the LLM models that works on text to text. Palm LM2, Claude by Anthropic, GPT-4 by OpenAI, Llama is again by Google. So this is all the generative AI models that will work on converting text to text. Say for example, this is your text. Now see the image onto my right side. I have given an input prompt saying that the input here is a text. Andrew is free from 11 a.m. to 3 p.m. Jonah is free from something from noon to 12 p.m. and then 3:30 p.m. So on Hannah is available, and some context of the text is given in 4 to 5 lines. This is an input, and you're asking your model to summarize what that context is all about. See how it is summarizing. I have highlighted the output here onto my right side. Here's a list of their availability: Andrew, Jonah, and Hannah. And based on their availability, there are 30 minutes window space where all three of them are available, which is from 4 to 4:30 p.m. So the meeting can be scheduled at 4 p.m. It's so simple. So this is being done by the generative model. So this is from text, and you want the output also to be in text. So it sits and works on, see here, GPT 3.5 model. This is the transformer model that your prompt will sit and work on this model, and it gives you the output. Got it clear? So this is how text to text it works out. Then you have something called as Llama 2 is given by Meta. So this is a fine-tuned large language model where this was introduced or released by Meta AI in 2023. Llama 2, this also purely works only on text-to-text conversions, where you have a very natural language processing tasks that will take place. So from the text generation to program coding is also possible here. See, nowadays, the job seekers are finding the persons, or he want the experts, or he want the students to get placed in their companies, where they look for the students not to write the code from the scratch, either in Python or in Java or in any other languages, whatever they need. What do they do is they are giving a short set of already coded, some coded data is given as an input to them. Okay. And the developer could be a software developer or whatever, whoever may be. He wants to customize the code, and he wants to tailor that existing code given by the team lead. The team leader will give you the set of code, and you have to read and analyze the code and tailor and customize the code and give as it is being expected by the user or the customer. So you need not tailor the code, or you need not start writing the code from the scratch, where it will be where the other persons will not be able to understand what your code is all about. So this is how the new trend of the companies who are hiring the Gen AI engineers and prompt engineers. They have the job opportunities available in the latest markets now, and there is a huge opportunities being given for a prompt engineer. That is, in US you get about $50,000 right now if you are being a very good prompt engineer. So nothing but you should know how to question the LLM model. The way you question them, the output could be more precise, and the output could be in a more in a more concrete way. So the way you question them is more important there. So the way you write your prompt is the prompt engineer's job. And for this job right now, you have been scaled to give around starting of $50,000. So this is the hike of what a Gen AI engineer and your prompt engineer right now is needed all about. So it is only the tools we learn, and you should know how to enhance the tool, and you have to tailor or customize your code. That is more than enough. It is that simple, and learning these codes or not not something like you have to learn the grammar, you have to learn the semantic, syntactic, syntaxes, and then you should know to learn the control statements, where to fit in and where to not to fit in. It's not that struggle you take it out. It is that simple, the code is, but you should know how to use these set of tools to tailor your existing code and reproduce the output at the customer's end by no minute. So this is what the latest trend is all about. So your GPT-N by your OpenAI, this is your generative pre-trained transformer, your GPT-3, your LLM given by your OpenAI in 2020. As I've told you, hope these slides are not something new for you. I wanted you to learn everything. See, in my slides, whatever underlined in blue color is all the hyperlinks I've given. If you are not sure about knowing about it, click those hyperlinks. You'll be tracked to the authentic sites where openai.com, the sites I visited, and I prepared all these notes and the slides for my students. So this is the complete uh, uh, authentic data taken from the OpenAI platform, OpenAI websites, and this is what I prepared uh, for the children to get them educated with. So it is a decoder. So I've told you this GPT is completely a transformer model which uses an attention mechanism with 175 billion parameters. You think about it, to add a two number, how many parameters we need? To add two numbers, so we need two parameters, that could be A and B, we want to add. You think about this model uses 175 billion parameters. You think about it, how healthier and how clumsy the network will be of, and it gives out a wonderful outputs, a very more realistic outputs. So you should be very wise enough to ask a question to an LLM. So if you are very wise enough in designing your prompt, we call a separate engineering called as prompt engineering. So you should be able to design the prompt very clearly, and if you're able to engineer it properly, the more precise and concrete output that you can enjoy from the model. So this is what I just want to give you. And your GPTs, nothing but your pre-trained transformers will work on these four techniques actually. You can have a pre-training. That means whatever I've highlighted in red colors or the important terms. See, your GPT will learn the grammar. That is, from the model, it will learn the grammar and it will learn the real fact. Fact is nothing but your raw data. And some reasoning abilities, underline those words. See how the words are very accurate and very meaningful. It learns the patterns. I've told you, Gen AI will learn the pattern, not the data. See, it learns the grammar, it learns the facts, and it learns the reasoning abilities. See how it learns from an image. Suppose if image is given as an input, see, these are the things it learns from it. And these are the things that you need to get pre-trained. If you want to pre-train a model, these things you have to concentrate in pre-training a model. And then after pre-training, you have to fine-tune it. Fine-tune it on a smaller and more focused data set. You have to give a clear picture that once if the training is over, you have to go for testing. Am I correct? So how you're going to test it? What type of data you're going to test? What is the amount of data? What is the accuracy of the data you want to test? So focus on the amount and focus on the data set in which you want to fine tune those results and get your intended precise outputs. Sorry. I'm sorry, 1 minute. Ma'am, is my slide so visible?
Yes, ma'am, we can see
Yeah.
how GPT works. Yeah.
Yeah, thank you so much. And then that is how your fine tuning your second point goes by. And then you have something called as tokenization. Tokenization is nothing but after you get fine tuned it, we want to divide that that input, the prompt into smaller parts or smaller fragments, that fragments should be more meaningful as well, and then segregate them into an individual characters. So this tokenization takes place. And these tokens are converted into a numerical representation. So something we call that to be as a vector representation. So you take an input of a prompt. The prompt input can be image, text, audio, video. What do you do from that? That is, you convert that or split that input into small tokens, and you convert those tokens into numerical representations, nothing but your vector representations. And then this is given as an input to your transformer architecture. That is your LLMs. So this will sit on your LLM, and your LLM will be working with your self-attention mechanism. Then it will finds out the answers and gives the output. So this is how it will be working. So apart from this GPT, can you give me some other LLM models? Okay. So Google's Palm 2, nothing but pathways language model, which takes 540 billion parameters. This is a transformer based LLM developed by Google AI. Then Llama is given by Meta AI. These are all the providers. Then Claude is an LLM model that works in Anthropic. So the very latest and popular model is only your GPTs. And BERT is also not that much popular. Okay, so Claude is one of the things. Then the features of Palm 2, that has 3.340 billion parameters that uses out. And then this is the links, whatever I've given will take you to learn in more depth. Then these LLMs are meant for giving a multilinguality. That means it can reproduce multiple language translations. It can be used for reasoning and training. It can be used for coding also. Okay, that data set also it can be used for. Say, for example, MedPalm 2. If at all you wanted to design a Gen AI model for medical purposes. See here, I have given an image of the X-ray or MRI scan of the complete four-armed hand. See now this four-arm hand, it gives a response. The prompt is an image I've given. See the response here is that it has founded out some findings, and it has given some impression. See, that is highlighted. That is a fracture, and this is the intermediate assessment of the distal ulina. Some all clinical techniques or clinical verbs are being used in identifying what is something wrong with this image and what is something the image talks about. So this is how it gives you the output. See how wonderful this model, this Palm 2. Palm 2 is given by Google. And see how beautifully it works. This model takes 540 billion parameters. You think about it, how accurate it can predict and it can give to you. See the wonderful the Gen AI model works out with your Palm 2. So you have another model called as SecPalm 2. See, SecPalm 2, now we are coming out with various security issues in all trust areas like food, water, and what to say, energy. These are the very three important trust areas of our research could be of for the welfare of your society. So in either in food production or in water production or in water scarcity or with your energy, without food, water and energy, like we can't survive. The energy could be in different forms, the water could be in different forms, the food could be in different forms. So the research on these thrust areas has to be secured, and it has to be properly trained. So this SecPalm is one of the very important security use cases being used by the cybersecurity analysis, and the Google Cloud gives you this opportunity to use it anonymously by the students and the researchers, and come out with their own findings in a more secured way. This is very important thing. And Llama is one of the very important LLM. See, the very popular, the LLMs is your GPTs, we know. This is are all the LLMs. You should be able to know about it and use it in your researches as well. Llama is the one that is a large language model by Meta AI, and that was released the second version. I'm sorry, the latest version of Llama 3.1 is released by July 2024. So this can be used. And also Cloud is the latest model they have released in 2023. This is an Anthropic's language model that was also been released. So where this model can be used for coding, for some mathematical calculations, and for reasoning capabilities. So you see the wonders of these models. So you should be able to learn and understand these models and apply for your of your research areas and get worked with that. Now, so far I'm talking about a data modality called text and image, text to text. Next we say text to images. See the picture here. I give here the text prompt. What is the question I'm asking the Gen AI model? An armchair in the shape of an avocado is the question or the prompt I ask the model. But what is the output I'm getting it here? See here, an avocado shaped the chairs, an armchair. See how beautiful it is. How this will be useful for the production of the furnitures or the creative interior decorators. Can use it very wisely. These models they can reproduce it. This is a one example I've given you. So what model can I use for this? DALI E2. See here, DALI E2 is a diffusion model that purely works on images. Please remember, if you're working on images, please convert that into a Gen AI model. All your researches will could give you a very wonderful output by using this set of models which are already being used. 12 billion parameters you can use it that could reproduce a very beautiful images of it. See here, see the text prompt. See, I'm talking about the image at the top. The text prompt is a storefront. You want to display the images of a store where the board of the store tells about OpenAI written on it. See how many images it produced. Is this a real image or this is a generated images? So we are not sure of it, but see the different captions, the style of those fonts, and the projections where it is getting a 3D or a 2D, whatever may be off. So that is how it generated. See the text prompt. See again, I'm talking about the image in the lower part of the slide. See now I give a text prompt, the exact same cat on the top as a sketch on the bottom. See whatever you see the image in black color, okay, I want the sketch of those images. See beautifully it is sketched out. You think about the variety of applications where you can use this. See how creative the developers of Google AI are there. They have overruled our ML and DL. Not only we started studying and trying to implement it out, but they have completely overruled in 2020 itself. We are 5 years ahead of knowing these things. Whereas in foreign countries, they have started implementing this and they were already into their life of using this. So we are 5 years ahead of knowing now only what is the Gen AI models are all about. Now here, the third part I'm going to teach you about here is a text to an audio. See, you want to convert something in a text. You want to convert that into an audio. See, like I'm teaching you uh, in a textual format. Like, am I right? I'm speaking in English, and the words are coming one after the other. And the words you frame into a proper grammar, you make into a meaningful sentence, and that makes you understand what I'm trying to tell you. Suppose if I sing a song in English, so will you be able to understand that is related to Gen AI model, which is very difficult for you to understand what this speaker is talking about and what she's trying to tell or orient us? That's very difficult. So this will generate an audio clips and music from the text automatically. So can you name a model that can convert this? See here, jukebox is a model. See, OpenAI is giving a model. So how are we going to implement this? I'll take another 5 more minutes. That how we generated the lab components is all that. You go to openai.com. You have a playground. You have something at the right end popping through it called as a playground. So you can play there with the different prompts, and simultaneously it can give you a wonderful outputs to you in whatever like you wanted the input. You give us proper prompt, it can give you. Suppose if I want to use a model to convert an audio into a text. Okay, so how do I use the model over there? Is that you create an API account with the openai.com. So you're an authentic username and a password, it will generate. So with that API username and the password API account, you come to your laptop or your standalone system where you can generate your what to say, you can generate your own Windows, what is that, variable, environment variable keys. Okay, where you can create an access to your operating systems, and that will be your local host. Your system will be your local host, and you take that OpenAI account details, username, and the and what is called the API keys you give as an input to your environment variable. That will stimulate a bridge between the OpenAI model with that of your local system. So whatever the prompt you type here in your local system, that will go and sit on the OpenAI model in openai.com, and whichever model you want to use it, you can use it off. And the number of tokens you use it, you will be charged. Say for example, like a token is not about, say for example, the tokens are nothing but the number of, see, when I ask a question now, or when I use a prompt, the number of words in the prompt. Okay, say for example, what is the text prompt here? A storefront that has the word OpenAI written on it. This is the prompt. How many words are here? So the number of words is not equal to the number of tokens. Maybe 5 words may be equal to 1 token, or 10 words may be equal to 1 token. It depends on the models. So like 1,500 tokens, or like 2,000 or 7,000 tokens. That is maybe like $5. You pay to OpenAI, and you can use 5,000 tokens in accessing any model under OpenAI, and you can complete your project or your research or everything else. So this is payable. Everything is payable. Even Google giving a Gemini is also payable. And but there are some resources now, it has come up with the last 6 months, that they are providing all these Gen AI models for free of access, but that too for a limited access with their tokens, and they are limited. Maybe in near future this might be completely free where we can use it off. So Jukebox is one of the OpenAI where you can convert your text to that of your audios. See here, this is wonderful. See, when I give audio to text, I sing a song, but I want the output, what the song is all about. Okay, so the whisper is the one. See, I've given something in green color in my text. Can you see there? Whisper one, that is called as a model. Okay, that will automatically, that is by OpenAI, that will convert automatically your audio to a text. See, I'm giving an input. A file is given as an, I'm giving the path where my where my MP3 file is there available. I want to convert that into an language. ENG is the code for converting into an English language, and the response text is given as a text. See, this is a small 4-line code that is being done in the model for converting audio to text. See how simple it is. See here, I got the output. This is what my audio text file converts. So with this input, with this text as an input, the next what I am trying to do is that text is given as an input to a model. See, I'm using the model GPT 3.5 Turbo, is the model given by OpenAPI. This messages is a function that has got two inputs. One is role. Role is a user, means we are the user. We will generate the prompt. What is the content means what is the prompt. Content could be in a text content. We are not giving in an image or an audio or a video, text content. So what is this? What is the prompt here? Generate 3 multiple choice questions from the text given. And I want a response back. See, the text is this. It takes this input and it generates 3 quizzes from that. See, from an audio file, I'm converting that into a 3 quizzes. See how it reads this file. It reads this complete sum of data and it generates the quizzes out of it. See how wonderful it works. So this is normally a GPT 3.5 Turbo works on this. So these all could be the examples that I could tell you on this. Then text to video. Text to video is also possible. Text to speech is possible. Speech to text is what the one I have told you about Whisper and about speech GPTs. So this all could be the text to video. We can use it a model something called as Finaki and Emu videos. So these are the example models that we can use it. Hope I'm clear till this. So what is here about image to text? Say stop here. Any doubts? You have it. I can clear it and I can proceed with the other slides. I have another 30 to 40 slides are there pending. If you have any doubt till here, ma'am, I don't understand the basics. I don't understand the data modalities and all the other things. If you could give me 1 day time, like still more, I can execute and show and how this realistically, how does it work? It will do wonders. But anyway, can I proceed with this? Yes, can I proceed? A response from you?
Yes, ma'am, you can go ahead. They've all chatted in the chat box. Yes.
Yeah, okay, ma'am. Thank you. And now you have something called image to a text. See here, you just see the picture on to my right side. It's a man standing on the rocky hill. See, this is an image I've given as an input as a prompt. And this is the output I've got it. So the image converting into a text, it's that simple, like it gives you the real images. Now, image I'm giving as an input and image I wanted to have as an output. What is something called as neural style transfer? See here, you see here the image. There is a porcupine. Okay, the image, I'm talking the images from left to right. See, there is a porcupine in a small cup saucer. And you can see something like a rainbow color getting circled here. So this is an image and this is the style. That all that what is that called? Like an the different colors, the styles we have it. Okay, like a rainbow colors. So this style I want to impose on the image. You see the output here. See the original porcupine and see the output onto my right extreme. You can see that the porcupine is being diffused by the by the style. See the style I have given in different colors. Now the porcupine is in different color. Is it in different mode? So this is called neural style transfer. So if you want to identify an application where you can use this neural style transfers, NST, we call that to be image to image applications. So this could be the example for that. Now, you see this image. I something call this to be as an in painting. In painting, see here, I talk about the image here on my left side. Can you see a girl sitting where her right arm is not seen? in the left portion of the image. Yes, you have a very fantastic tool called to be as an in painting. Okay, that is given. You can draw and you can draw a part of an image that is lost completely. See now how beautiful the image on the right side with her right hand is visible, and how beautifully it is being crafted. So this is how the in painting, either it can remove the defect of the images or it can enhance the complete appearance of your images. So this is how in painting also works out here. So I have some of the codes also which could generate an image from the prompt using DALI in OpenAI and everything. So these codes are runnable codes which could convert and take an image as an input, convert that into a text, and what is this image or output, it can tell you. So if I start explaining this, it will take more time. So I'm skipping off this. Then coming to text to code, write a program in Python for uh, for checking the plagiarism in the following code. So it can write a program for checking the plagiarism in Python. It can write a program to check the plagiarism in Java. It can write from text to a code is possible. Video to audio is possible. Text to math is possible. See, everything is possible. You're telling what is not possible with GPTs. What is not possible with language models is this. I'll take you directly over here. What are the limitations of these LLMs? You will wonder. Can you see here? Can your GPTs or your MedPalm or Claude or whatever the LLMs you have seen here, whether do you think they produce the correct answers? See here, I'm asking a question. What's LangChain? And your chat GPT is giving, see, read the first line. As of my last knowledge update in January 2022, I don't have a specific information about LangChain. See, do you think that LLMs are giving you the correct answer? Will give you the prompt answers? Though they can generate a new content and they could give you a proper decision making. See, now my answer is wrong. It's not giving the correct answer. Okay, I'll go for some math. Text is only giving the wrong answer. I'll go for some mathematical calculations. See here, what is 2555 into 2555? It's giving me a wrong answer. Math solving is not possible. It gives me the wrong answer. Do you think that that has some limitations in their functionalities, or do those APIs doesn't work, or what's the problem? Lack of context and biases and discriminations, because they are biased with some certain responses and they cannot act in nature as what you expect it. So they are actually pre-trained models. Okay, whatever we are getting trained with them, they give us some output. And that output we cannot rely completely. 100% accuracy we cannot give, but to some extent and to some transparency can be working on it. But though at sometimes they fail. So this is lack of transparency over there. So this could be the limitations of your LangChain is all about. So here, when I ask the same question to OpenAI Playground with GPT 3.5 Turbo or GPT 3.5 as my model, then it gives me the correct answer. So due to inefficient knowledge on certain topics, the most recent information LLMs generate will be the incorrect responses. So this is an example I've given you. So how to overcome these limitations? You tell me. The LLMs are finding it. See, the first part I talked about all the wonders of these LLMs. Am I correct? The second part I talked about there are some limitations, whatever they produce or not to their extreme. There are some limitations. Now I'll tell you how to overcome these limitations. Something called as retrieval augmentation. This is very, very important. See, please read the first sentence. Retrieval augmentation is nothing but we call it to be as RALM, retrieval augmentation language models. So where they use external knowledge bases to supplement the LLMs. That is what they use it. See here, I'll directly take you one diagram so you can understand that. See, now listen here. You just look into the diagram here on to my right side. You have something LLM. The LLM can at times your LLM will give you a wrong answer, isn't it? So we have to use something called as RALM, that is retrieval augmentation language models. So where they are connected to external resources. See here, you have your own app, you have your own data, and you have your own logic, and you can write a function for it. You can connect with the LAN chain. LAN chain is very, very important concept in your Gen AI model. And this whole phase is called as a LAN chain. And this LAN chain will communicate with your LLM now. Got it clear? And this is how your LLM is enhanced with some external data sources. Now, when you come here, uses external knowledge bases to supplement an LLM. What are all the external sources? Can you give me some more examples? See here, I could give you some more examples of this. See here, this is are all the tools, external tools. I can connect with Google, I can connect with SQL, I can connect with Wikipedia, I can connect with Tavily, DuckDuckGo, SIRAP API, and RIV. These are the external, what is this? External repositories of data where your LLMs are connected with this and they can reproduce still more. See, now your LLM cannot say that I don't know the answer. When you ask your Siri, what is my father's name? Will your Siri answer who's your father's name? It can't. Then who was the prime minister, first prime minister of US? Who was the last prime minister of US? Until the database is getting updated, your Siri or your chat GPT or whatever may be off will not be able to get the latest information. So this is the tools that it needs to get the external resources getting connected to it. That is what we call that to be as a LAN chain. Very clear? We are connecting and chaining with those tools. See now here. See here how your AI agents works with the LAN chain. Okay. See here, you have a short-term memory, you have long-term, because I need to remember something. Your LLMs needs to remember something, so it's got some memory. Now there is something called as an agent. This agent will work with some tools. That tools, it needs some calculator, it needs some calendar, it needs some code interpreter, it has to get some search engines, it has to go with some search engines and more tools your LLM needs to get connected. Only then it can do the planning. And see something in dotted lines onto my right side. It can give the proper self-critics, chain of thought, sub-goal, and it can give you the proper reflection of what the user actually wants. Got it now? Though your LLMs are working wonderfully, but there are some limitations, there are some oscillation risks where it is limited. And how to overcome the limitations is that you want the LLMs to get connected with their other external resources like various tools so that it will be able to give you the proper answer. Got this clear? So this is how your AI agents, see here, a particular task is nothing but a prompt is given as an input. It comes to an LLM, and from the LLM, it accesses the tools. And the tools will work on a particular environment. You're talking about what? You're talking about medicine, you're talking about climatical changes, you're talking about commercial market, You're talking about stock market. Based on the environment, it'll give the results, and the result is taken back to the LLM, and the LLM will give the proper reasoning out in giving the answers. So this is how an agent in your LLM will help you out in connecting to various tools and gives you the outputs. This could be a very good example. See here, the bulb, whatever you have is an agent that is works with your LLM. Got it? This agent will connect to tool 1, tool 2 is there, and tool 3 is there. It will connect to different tools, and then it produces the different, it connects to Wikipedia tool. The second tool, it connects to the calculator for some math. The third tool, it connects to a reasoning tool. Now your LLM becomes perfect. It can answer everything, not designed on its original data when it got during its inception period. Means that during the time of creativity, during the time of release, the model is fed with some amount of data. With that data, some intellectual questions cannot be answered. So your LLM fails. So to overcome this, LLM uses the LangChain that uses the agents as an intake, which takes more number of tools that will get connected, and then the LLM could reproduce a very good response back to the user. So this is a very important slide that I just wanted to tell you. Say, for example, how many countries are there in Africa? It is, you have something called like a butterfly, like a flower type. That is your LLM model. It goes to a thoughtful tool. Agent is acting as a bot here. I need to find each country in Africa and add them together. See, I want a math here now. It goes to Serap API. It searches and finds the answer. There are 54 countries in Africa. This observation is given as an output to the particular task. Got it? So it uses Serap API tool. It uses calculator as a tool. Then it finds the answer and gives the output. So this is how intellectually it has to work. Always your limitations of your LLM is with your outdated knowledge. You have it. This is what I have told you. And how to overcome that is retrieval augmentation by using some chaining and prompt engineering. You can overcome by fine-tuning it, you can overcome. So the LangChain is the very important concept. What I've told you is ChatGPT was released in year 2024, but its knowledge base was limited to the data from 2021. See here, it was released in 2022. It has the latest data up to 2021 only. Now 2024 data, if you ask them, it is finding it very difficult to get it searched. But the latest data, if it wants to know, it wants to connect with external resources. See here, I've connected with vector store, prompts, agents, chains, LLMs, and documents. So these are all the external tools that could help you out in making your LangChain more successful. So this is the example I've told you. See, when you ask your LLM, who's Dr. Vijay Lakshmi? Okay. So LLM may not be able to find it out, the answer exactly. Who's this professor is all about, where she is working, and what is her history in an academics, and and what are her roles and everything, research contributions, and all the other stuff, isn't it? So you have your own logic, your own data, write a function, combine it, make it as a LangChain, connect with your LLM. And now if I ask a question about who's this lady all about, it could be able to fetch your data from your local Wikipedia and could give you the output as what is expected. So this is how it works. This is how your LangChain will work. I'll just explain you. This is a large document, whatever you have it, that is broken down into small chunks, and the chunks are stored in a vector representation, and that is given as an input to your LLM. And what I have told you is here retrieval information or retrieval augmentation. That is your external sources that are binded together along with the LLM. And now the LLM will give you the proper responses at the end. That is in different slots you can see that get reply off. That is how you get it. This is what a lag chain is all about. Hope the time is up. So with this, I'll wind up. So with this I just wanted to tell you what is all the diffusion models. See, this is by DALI 3. The image generated. I'm giving the prompt. A white tiger with intense cold-blooded eye in the midst of a snowy landscape. Okay. The tiger is captured mid-jump, showcasing its powerful physique in an Antarctica with polar bear. This is the prompt I'm given. This is the text I've given as an input. My output is this image. You see how realistic the image is. You see the image of a tiger. See, it is an Antarctic place. It will be very cold. Polar bears are there, but the lion or the tiger is so fierce. It is jumping over. See how the images are generated by DALI 3. See, these are the other images. Titanic ship and a real scenery image. Images by stable diffusion, the prompt. Okay. A luxurious interior living room. Here, a cute puppy watching a movie in a theater or in a movie room. See how realistically it is given out with a popcorn snack. How curiously it is watching. And see, the eyes of that dog is reflected by the image light of that movie also. See, that is how the accuracy it reproduces. See, image is generated by the mid journey. See the image on the right side, a bottle, where inside that you have to carve a image, a realistic image of a deer is sneaking for its water or praying for its food, something like that. See, a polar bear is swimming, and whatever a sloth is holding a treasure and a dog. And see, once yeah, I give only the text. Imagine is again a model generated by the providers. See how beautifully they are giving the images here. And this is a very good diffusion models I've taken from the authentic websites. You can learn more on these models. And I would just like to tell you that suppose generative AI program, this handles out. Google is providing a free courses on this. Introduction to Generative AI, Gemini for Google Cloud, and Generative AI for developers is completely, this GenAI program is free for the students and faculties, and they can enroll for these courses and get their digital badges awarded. But there are some timings that you could get enrolled and get benefited. And last semester, when I was handling this course, I have given this to 2,750 students, got benefited in using Gemini as a tool for their projects and as well as for their execution of their lab exercises also. We also used and executed the programs using OpenAI tool also, and also with the Gemini also they have used. This is completely a free, and they have earned the badges, and they have done the many projects, and they have uploaded in GitHub, and those links were given in their resume, and really like 20% of the students got benefited because of these courses. This is an global certification courses given by Google for free for a particular period of time to students to get it explored with their Gemini tool. And this could be very good useful for the students as well. So if at all you all want it, like, I can communicate with your organizers in giving you an exposure and getting enrolled for these courses and get benefited as well. So thank you so much for patiently listening to my lecture, and I hope I have given you an insightful introduction to Gen AI and where the future is all about. And if you could have any doubts, regarding to it, you can raise it in this forum right now.
Yes, participants, if you people have any doubts, you can always post it in the chat box so that ma'am can answer your queries.
Ma'am, hope at the right time I have completed, I believe.
Yes, ma'am, you are on dot.
Yes, thank you.
Participants, we'll give you another 2 minutes. So any doubts you people have, you can always post it in the chat box. Yeah, I think there are no queries. They have told one Shami L has asked for security issues with Gen AI, ma'am.
Yes, yes, yes. Ms. Shami here, the security issues with your Gen AI is that we use the model called as the SecPalm 2 models. So that could help you out both with your cryptographic securities as well with your security with your Gen AI models as well.
They have also asked to share the link where the students can enroll for the courses.
Yeah, sure, sure. I will just hand it over to the organizing team so that they can get in touch with it so that the students can get enrolled and get benefited for that as well.
Yeah, sure, ma'am, sure. Any other queries from the participants' end? Okay, so I extend my profound gratitude to Dr. Vijay Lakshmi P, professor at Presidency University, for delivering an erudite and captivating discourse on generative AI and large language models, practical insights, as well as future scope. Thank you, ma'am, for discussing about the differences between machine learning and Gen AI, the definition of generative AI, types of generative models, how the GPT works, and also the large language models LLM and its limitations, LangChain and its working, as well as with the diffusion models. So, your deep expertise and articulate elucidation of this transformative technology provided invaluable perspectives, enriching our understanding of its vast potential. We sincerely appreciate your time, effort, and intellectual generosity in sharing your knowledge with us, ma'am. Thank you once again, ma'am. Thank you once again.
Yeah, I would like to thank every one of the participant and the organizing team and the management team for having given me this opportunity to really, enrich or motivate the students for this latest trends, and hope I could give you near future also about these latest tools and the technologies. Heartfully, I once again thank every one of you of this university and the college and the team also. Thank you so much.
Thank you, ma'am. Thank you once again.
Yes. Yes, ma'am. Can I leave the session?
Yes, ma'am. Yes. Thank you
Yes.
so much.
Thank you so much, Marisa.
Yeah, madam. Thank you so much. Thank you so much.
And now I request Professor Priyanka to introduce our second speaker of today's session, Dr. Rajan S. Sir has
Thank
already joined. Priyanka ma'am, make sir as a co-host.
Yeah, thank you, ma'am. Thank you so much, Valima. Good evening, everyone. It is an absolute honor to introduce our esteemed speaker for today's faculty development program, Dr. S. Soundarajan, a distinguished academician, researcher, and visionary in the fields of artificial intelligence, cybersecurity, and computing technologies. Dr. Soundarajan S. currently serves as the chairperson of the Department of Computer Science and Engineering at Amrita Vishwa Vidyapeetham, Chennai, With a rich academic and research career spanning over 2 decades, he has held key positions at VIT Bhopal and Banari Aman Institute of Technology, contributing significantly to curriculum development, program leadership, and research innovations. A prolific researcher, Dr. S. Soundarajan has published extensively in Scopus and Web of Science Index journals with over 500 citations and a strong research impact in AI, deep learning, and high performance computing. He has guided PhD scholars securing funding for major research projects and established centers of excellence in cutting edge domains such as cloud computing, IoT, and robotics. Beyond academia, he plays an instrumental role in international collaborations, editorial boards, and industry academia partnerships, furthering advancements in computing science. His expertise in AI driven cybersecurity, machine learning applications, and digital transformation makes him a thought leader in the field. Today, as he shares his insight on future trends for societal consequences of emerging AI technologies, I am certain that he will gain a wealth of knowledge and that will shape our academic and research endeavors. Without further ado, let us extend a warm virtual welcome to Dr. S. Soundarajan. Over to you, sir.
Thank you, ma'am. Thank you for your brief introduction. Am I audible, ma'am?
Yes, sir, you're audible.
Yes, ma'am. Thank you for introduction of me. I am working associate professor, Amrita Vishwavidyapeetham, Chennai campus, act as a chairperson, Department of Computer Science and Engineering. So today, my presentation is visible.
Yes, sir, we can see your screen. I think you can go for slideshow, sir. Yeah, we can
now
see
it
now.
is okay.
Yes, sir. Yes, yes.
Yeah. So already one session, now it's getting over. So many participants are available here. So now we can move on to that next session, future ready AI emerging technologies and their societal transformations. So first of all, I want to know that you other people are more emerging people and understanding of technologies. So first of all, we need to understand about the buzzwords of an industry and academia nowadays. So everybody is talking about artificial intelligence is a broad domain. So that is a topic, it is not a new one. Already we know that the history of AI and how the technologies are evolving now. Then today is a curriculum, it is completely driven by AI. So now we are in the phase of second phase of AI. So we are not in weak AI, we are in strong AI phase. So after 10 to 15 years, it will be moving under that super AI. AI is surpassing of human. So we are in the intermediate era. So we need to understand about that AI tools and technologies. It must all faculty members and students. So that kind of faculty development programs will be eye-opening sessions for all the students to understand and participants and understand about how AI will be evolving for future ready engineers, as well as for how the societal transformation happened on in industrial applications, as well as for sustainable goals. That is what the main agenda we need to understand here. So first of all, I welcome all of you, AMC Engineering College, to conduct this particular FDP. So I can say that I have conducted 2 offline FDPs of ATAL in 2024 and 23. So we have conducted 2 completely offline mode. Now they are offered in online mode. And first of all, we are moving into that session. So it is not interact just monotonously. I have talked something and then you are listening. So you have to be very interact and talk to me. It is very nice of me, and I can deliver more content, whatever in my knowledge. So first of all, first moving into that, we all know in the digital era, we know that knowledge Everybody's know that knowledge in your pocket. So we have a handheld device in our hand. So anything if you want, then you can see the handheld device and understand that. So if you know any mobile number, or if you want to open any application, mobile application, or if you go on browsers and any business logic applications and chat GPTs and a lot of mobile apps are available there in that. So if any doubts we are having in knowledge wise or understanding wise, so then we can move on to the mobile phone and then we can see, open the browser or open application, we can understand that. So this is the world now we are in. So not our brain and the computer processor, both are nowadays they are simulating. So we need to understand nowadays our brain is in a handheld device. That handheld device is like a smartphones. Smartphones, different people are having different brands. So that is the brain of the person. That is what we can say now. So everybody is having a handheld device with AI device. That is in our extra secondary brain in our hand. That is called the knowledge. We need to understand anything. If you want to browse a Google and then you can go on ChatGPT. Most of the popular companies are having their own LLM models. Then we can go and search and then we can understand the things, right? So first we need to understand, I can ask a few questions, how you people are understanding about that particular subject in AI, as well as the broad domain, I can say that. And you can see that AI, some subdomains are available in machine learning and deep learning. First of all, you can see the different tasks given in the slide, right? So we should understand that what is the common between all 6 tasks. Then we can say that, say any one of you. So any relation between all the tasks. So I can given to you. So any one of you, please tell me. So what are the tasks are mentioned in the slide and what is a task actually? What is the problem in the task? Which problem we can identify in the AI-based environment? May I audible, ma'am?
Yes, sir, you're audible.
Yeah. Any one of you, please tell me that you can see different pictures, right? So one picture is showing is it a fraudulent transaction, and another one is showing who will respond to this coupon. Is the best resume for my job, and then you can see what objects in the image. I'm being hacked right now. Is this customer about the charge? Right, you are not able to talk, right? So now I can say that. So these all are common tasks for the prediction. So these all are prediction problems, and I can show. Yeah. Yes. Any one of you talk something?
Sir, they have chatted in the chat box telling they are all cybercrime.
Okay, that is not relevant to cybercrime. I am talking about that how we can each and every task, how we can do it. For example, in the fraudulent transaction, you can do a different task. You can find, right? And the resume also you can find. Who will respond to this coupon? It is going to find. Objects also you can go into the find. So this customer able to churn for any Ola, Uber you can take, or any example of transportation companies, you can understand that. I am being hacked right now, also find. So all are how you can go and find and prediction. That is what I'm saying. All jobs are different tasks, and then these all are prediction problems. So we can go and predict something. If you find a best resume, we can go and predict, right? Fraudulent transaction, we can predict. So this is what actually common problem. And you can see here, what do these tasks have in common, right? You can see all different tasks will be there. Previous tasks is a prediction problem. Now you can see different types of tasks are available. You can say that first is a Google map, it is given, and AlphaGo, and you can see one mathematical equations also there, and different equations, same equation into different flavors, the same equation into writing in a different way. The same, if you substituting the value of x and y, the same results will be giving. And you can see in the conversational AI and the transport and also listening problems or hearing problems, and somebody is having the mental problems, right? So you can see here, and what is the task in between all six, and then we can say that what is the task actually in that. You can think in an AI oriented way, and then you can say that's it. What is this actually? What problems? So have you find anything? So these all are reasoning problems. So first of all, we need to understand here what is AI. So we can define AI in multiple ways. So first we need to understand AI. So AI is an agent. The agent demonstrates intelligence. That is a simple understanding of definition of AI. It may be a hardware agent, it is a robot or any other machine, or if it is software agent. But the agent, what will do? The agent will demonstrate intelligence. How they demonstrate intelligence? They can see environment, and then they can see, they can walk, right? They can understand about different type of environmental activities, and then they can see each and every thing through eyes. Eyes is not in that attached to the robot. That eyes is, it is like a camera. So we need to understand that is a hardware thing. We can attach a motors and hands, and we can rotate the motors. Even we can do anything with that hardware robots. So that is a hardware agent. So we need to understand here, AI is totally, we can dividing into 5 phases. So first we need to understand the first phase, the problem solving phase, right? Second phase is a knowledge phase. Third phase is a reasoning phase. So fourth phase is a decision making phase. Fifth phase is the perception and actuation and languages phase. So first we can come for the problem solving, right? If we go and learn about AI, we need to understand how the AI will solve the problem. It is a traditional problem and AI solving problem. We can understand very clearly in that, right? Classical problem, how we can go that. So we need to understand about AI in the searching problem and logical problem. These all are logic in AI, searching in AI. So first we can understand for searching in AI. For example, if you take any Google map, right, one place to other place, if you want to travel, we need to understand about how the path will be generated through one place to other place, how many path will be generated, and what are the connecting points, which one is the most effective point we can travel one place to other place. All connecting point dots we can connect as like as a path. So that is like graph, we can see that it's a graph problem, or we can understand about the tree problem. So we need to how to solve the problem. For example, if we go for search, right? In AI, we can talk about uninformed and informed research, right? We have a domain knowledge, or without domain knowledge, we can go on searching in that area. So that is what I'm telling you. We can solve the problem through AI. How we can solve the problem through optimized way and some heuristic knowledge. That is what actually problem solving. And you can have a lot of facts. We can store in a facts table. Facts is nothing but the data, right? We can collect all the facts and integrate all the facts through logics, and we can store a knowledge base, and then we can uh, question that. We can ask multiple questions to the knowledge base, and then we can understand what answers will be coming out. So through some logics, we can use it, right? That is a knowledge base we can create. We can understand about reasoning. That is a logics that we can go for the predicate logic and first order logic, right? So we need to understand about logics, and then we can ask questions and get back the result. How we can relate. So these all are no data-driven approach in AI. So anybody who wants to learn AI, no data-driven approach, we need to understand about problem solving as well as for knowledge and as well as for the reasoning, right? And we can go for that AI in the fourth phase of AI is the decision making. If you go for the decision making, then data is required, data set is required to make a decision. So then how we can understand about that? We can move on to that. Understand about the decision making. So the decision making, it is having recommendation system, expert system, it is like rule based system, and machine learning and deep learning all are coming under the decision making, right? So now we are learning about machine learning and we are learning about deep learning. It is coming under, it is like decision making phase, and we can go for the fifth phase of AI is a language. It is called natural language processing. NLP, we can talk about language oriented, as well as for the actuation, robotics oriented. And we can go for the perception, can see the real-time environment, right? That is a reinforcement oriented. This all are comprising is called AI, right? That is a subdomain of AI, we can say as a machine learning, and we can go in depth of large data we are having, then we can go in inside of the subdomain, we can say as a complex relationship, we can design a model for that relationship with suitable mathematical formula we can choose, and then how do we solve the problem, right? For a suitable mathematical solution, that is called, we can say as a deep learning. So we can see one by one. So right, so that is what, and the lecture we need to understand about how AI will be evolving, right? Just we can understand about AI will be evolving. First we can understand about intelligence, right? Intelligence is having four phases. First is learn and understand and think and create, right? So previous example we can see that these are our reasoning problem, right? So how we can relate, that is what reasoning problem it talks about, right? So we can see here, first of all, we can move on to that learn and understand and think and create. So first we can move on to that learn, right? Learning is nothing but we can easily understand ability to generalize a label or value or pattern for a new observation based on the model built for the past experience, right? We can see here different A, it is in representing here. A is a letter, different formation of letter we are representing here. And if you understand each letter very clearly is a label or value or pattern, right? We can, a new letter it is coming, then we can see the shape of the letter, and then we can say that this is A, right? So you can see all the symbols are like A only. So that is what actually learning phase, and how we can understand, right? Ability to assign meaning of to all the parts simultaneously based on the context, right? The whole as a context, we can say two lines, and we can compile all the lines in the circle. We can frame a clock. That is a overall context, right? Then we can understand this is a clock. So all the parts are make sense. That is what we need to understand, right? And we can go about thinking. If you see chess or if you see AlphaGo, right? How, what is meant by thinking is a solve to the sequential task, right? Solving a sequential task is like a thinking one by one. I can solve the first step and second step and third step and fourth step, right? We can see, you can see this is a one formula, right? This formula is x cube minus y cube divided by x minus y plus xy. I can substitute some values for x and y. I can get some value of this formula. I can, the same formula, I can rewrite into the different forms. We can say that. We can see in the different forms of the formula, you can substitute the same value, you can get the same result only. But I am writing the same formula in different formations, right? So I can see that. And again, I can write into the subdivision. Again, I can write into the subdivision. That is a task by task I can write. And finally, I can get some value. So all are the same way. Then I can write different formulation, and which route I can take and which particular goal I can reach into my end. That is what actually we need to understand for thinking. If you take a tic-tac-toe problem, it is a very simple problem. 3 into 3 cells are available, right? 3 factorial moves are there, right? So normally is 9 factorial moves are there. So 9 factorial, you know, 9 into 8, that kind of moves are available, right? You can have a 2 players are playing, right? One player is in X, another player is an opponent player. It is like, oh, there two players are playing, they're moving one place, and then we can know that what is a goal state, we know that, right? At is in vertical or horizontal or diagonal, then that particular player it is getting win. So you need to understand what are the calculation we can made as a thinking. So I can, where I can place my X, right? Then based on that, my opponent will move on another move. said that, right? So based on that, I can calculate into some formula, and the formula will be dividing into different formation, same formula only. Then I can understand, I can move and move, finally I get the result, right? For example, if you go for the chess, right? Chess, all of you know that 8 into 8, 64 factorial, it is there for moving, right? You know that chess legal moves are there. If any player it is playing, how many legal moves are there? 35 legal moves are there. If you go for alpha move, 240 legal moves are there. So we need to understand about each player it is playing, each particular position of the coin, it is how it is moving, what are the legal moves, and each and every space of the coins, one place to another place, we need to move. So we need to understand this context, right? If anything we can do that, this is a mathematical flavor is there in background, how it isn't going to find a better place, right? This is the thinking, right? And we can go for the create. So the previous session I have listened something about LLMs, right? Generative AI, we need to understand here. So, right, so you can see here, you can go on top of the slide. I was going walk in empty parking lot, and I safely returned home. So first sentence and second sentence, in between, I'm not inserting anything. If you go that some LLM models are available, right? GPT models as well as ma'am, audible, ma'am? Some
Yes, sir. Yes, sir.
yes. Thank you, thank you. And you can see here, and some values I need to insert in between. But what GPT models will be understanding, GPT models will check, I was walking in empty parking lot, right? What are that walking and empty parking lot? So you can see that suspicious. So then catch me, safety, and parking lot. So what actually is an empty parking lot? It means the system will understand. I saw the suspicious man who was walking towards me. A man started running after me. I ran as fast I could. And the man would not catch me. So this insertion, not human it is, but LLM models will understand the statement, and we can inserting a new sentence based on that what context of the statements we are writing in that. So this model will check each and every keyword, right? Which keyword is uh, it is species keyword, or which keyword is that we can given in the system, that based on that the new kind of sentence will be forming, and then create and then inserting in between the two sentences. That is based on the LLM models, right? So first we need to understand here. So intelligence is nothing but we can learn, understand, and think and create. What is mean by artificial? That artificial, it means that we need to create intelligence with artificially. Artificially, it is like a brain thing, right? It is not a biological brain. So we can make as like a brain, and then that brain will be doing an intelligence, right? Right, we can see here. This is a very important slide. We need to understand about AI sectors. You all know that, right? What are the sectors we need to understand? I can take some of the domains here, and like I can call as a sector. So first, agriculture sector. So a lot of people are doing projects in agriculture, and they can deploying a lot of sensor and IoT projects. People are doing for different problem statements, right? And education is a biggest concern, right? And we need to develop a lot of application in AI for personalization of the student based on the curriculum, right? Each student is having different skill set. They are coming for the rural background. They are not good in mathematics. They are good in science. So all the people are coming together and learning in engineering college, right? So how the curriculum is looking like, that we need a lot of experimentation in AI. So we need to understand about create a lot of applications, right? And healthcare also, it is a broad domain of sector. So we need to predict a lot of disease, and we have to give a lot of solution for different problems. And energy and security, all are sectors. We can take different sectors also. We can take for understanding purpose. We can take 5 sectors here, and we can see here who are the beneficiary of the sectors. I can take an education, right? You can see here education It contains who are the beneficiaries, students and teachers and institutions and labs and IT industry and educators, right? We can go for application, right? I can create application for the institutions, right? Applications are different application. I can generate, I can create an ERP application for my institution purpose, right? That ERP application is about the student or about the faculties in the institution or institution growth and anything. It is an accounting software, anything I can create like a product or applications. And that application is required a lot of services, right? User services and content oriented and software services and AI and data services. Now I can opt for AI services. What are the AI services available? And speech and vision, language and knowledge and IoT, right? And you can go for producers. So the producers is like I can take like AI services in vision. I can go for vision. I can take as a service for like a computer vision, right? And who are the producers and researchers and education and startups and students and companies? This is the producers. So what we can understand this entire diagram. So now where the AI is placed here and what AI will be offering to the producers. Now we can clearly understand we are not scratchily develop application through AI. We are adding some layers of services. That AI services is not a single service. AI is having multiple services, right? And we can provide speech services and vision oriented and language oriented, like NLP oriented and knowledge oriented services and IoT services. And we can go for language. It contains all text and LLM models, everything it is there in the language services. Which particular services we need to produce to the producers, right? So here AI is a layer to understand about our application to in between the application providers and producers. It will be providing the particular service, right? That is what we need to understand here. So we are creating application not through AI, right? So we are creating application and adding of AI layers, and we can provide the services to the producers. That is what we need to understand here, right? So everywhere, so what people will understanding of that particular technology, they want to be create AI based application. They want to be do something, right? So that application is required. If you develop an application, it's like a AI, we can add AI algorithms to that application. That particular application is acting as an optimized way of understanding of customers, right? We need algorithms, right, to provide the service. If you go for speech orientation of algorithms, we can add vision oriented algorithms, we can add. For example, in computer vision, you can go for image oriented. We need to go for CNN oriented deep learning methodologies and algorithms we can add and providing to that. So we need to understand here entire diagram is in how AI will be producing for the services to the producers, right? You know that this products evaluation and right and product 1.0, 2.0 and 3.0. So product 1.0, it is a programmed devices, right? We know that in earlier cases, 1980s and 90s. So that cycle, it is a cycle, is a mechanical device. It is a car, it is a mechanical device, right? It is not intelligent device. Now you can come for 2024. If you take any one car in any one motor company, that is all are integrated with the sensors. All cars are very intelligent way of doing that. Advanced driver assistance system also attached to the car. The car will be understanding about land or understanding about nearby cars and automatically applying for the brake and everything it is doing now. So previously it is in 1980s and 2024. The car, it is not like a car, it is like a computer oriented. All mechanical components are connected. It is connecting through, it is like a system, right? We need to understand the product evaluation, right? So that product evaluation market is totally different, right? Here we can see that in intermediate and product 2.0, that internet booms, right? Google and large crowding network areas like LinkedIn and so we can connect large number of friends. That first we can connect friends and then we can share information. Information is nothing but video, audio, and we can share text images. And you can go for the YouTube. YouTube, it is a like collection of videos, and you can see all videos in terms of contents, and you can go for the recommendation. So this is have a crowd intelligence. So many people are having a login and they're using for this particular product 2.0. And product 3.0, it is an eco intelligence. It is like it is connecting of entire city or entire nation. Is like a ecosystem intelligence we need to create, right? For example, if you telecom industry, it is not like for Jio, it is covering only for Mumbai. Jio, it is covering entire India. So we need to understand this ecosystem intelligence, right? If you have a Jio phone, you can go anywhere in India. You have a tower, and then you can call to anybody, or you can share messages, and you can access the internet. So this is the evaluation products in 4.0 and 5.0. If we can understand that behavior characteristics, how the products will be developed and how the technologies will be integrated. That is the main thing we need to understand here for evaluation of products. And what is AI? So that is what I'm saying. AI is all about building systems or agents that demonstrate intelligence. That is what in AI, very simple terms we need to understand here. In our Abdul Kalam in 2011 conference, Dr. Abdul Kalam actually is telling that in 13 years before itself, right? Future interactions with the computer will be seamless. It will interact the cyber world just the same way you and I interact with each other, right? So this is what if in future, that is what I'm telling you in starting itself. We need to understand about what phase we are in AI. So many of people are talking our jobs will be lost because of AI. So now we are what phase we are in AI? It is a strong AI phase. AI, it isn't human, it isn't a straight point now. It isn't nearby surpassing of human in little bit, right? In 2040 and 2045, 2050, AI will be surpassing humans. AI will be like a human machines, right? That will be coming out, but who will be taking care of these jobs? And then there is a different scenario we'll discuss later. And the data, information, knowledge, and wisdom. So how we can represent data, how we can transform information, one data into the other, one person to other person, how we can transform, and how we can create a knowledge. I have a two data. What is the connectivity between the two data? And I have 5 facts like a raw data. How we can connect in all of raw data. How I can do that, right? Very basic example: X brother of Y, Y sister of X, right? Sister of Z. Then what is the father of A, and then we can easily connect it. Different data I'm having, how we can create a family graphs. That is a knowledge I need to understand, right? How what is the wisdom, and I can understand about the knowledge, right? So this is what we need to understand very clearly, how we can represent, how we can reasoning of it. So have a data, information, and how we can represent in the data and the knowledge, right? And how we can go for the wisdom, right? This is need to understand about any learners in AI. And this is what the main important things everybody will understand about how the AI will be constituting AI in data science. So previously I'm telling about AI is having 5 steps, and we can go for the data science. Data science also 5 steps. Data science is like a science to collect and store and process and describe and modeling. Total 5 phases, right? Collect. So we can need to collect the data, and how we can collect. Different methodologies are there. Data is available or not available. If it is not available, we can do experiment and then we collect the data. And how we can store the data. Different type of databases are available. We can store that types of data. We can understand structured, unstructured, class structured, and semi-structured. So how we can store. So different databases are available, right? And we can use some structured query and NoSQL languages to represent the unstructured data and structured data in different databases. And this is a store. And if you store the data and how to process the data, how to do a cleaning process and normalization, standardization, it is coming to the process. This 3 steps also no data-driven approach, right? Like AI is the first 3 steps is not data-driven approach. And you can go for the decision making. We need to understand decision making. Already I'm telling you, right? Decision making is nothing but, so we can see decision making is nothing but expert system, machine learning, reinforcement learning, deep learning. This all the part we can say as a decision making, right? Expert system, you know, all right. Rule-based system, we can create anything. It doesn't rules encoding using knowledge representation, as all our execution, the rules and reasoning done by the program, right? A lot of limitation also there. So if we can make time to time rules, as well as for the rules are too complex. Some rules are maybe unknown, right? This is the problem of expert system. That is why we moving onto the machine learning. So like y equal to f of x is like a function. We can substitute any value for f of x here, any function here, and then we can estimate and finding the value of y, and we can use some optimization techniques. And we can come for the reinforcement learning. Let us see the dynamic environment through the sequential decision making, and we can get it is not complete environmental ideal data. Then we can understanding for the partial information and no explicit supervision. And we can come for the deep learning. It's very large amount of high dimensional data plus very complex relationship between input and output with specific complex ML models and algorithms called deep learning. So this is a decision making. So we need to understand this diagram, decision making like. So if you go for the machine learning, we need a data set. If you do something in deep learning, we need a data set. Right? If you do something in expert system, we need a data set. Recommendation system, we need a data set. So here data is required. It is data driven approach, and that data is required. We need data science, right? Already we have a data, right? The data collected, stored, and processed, data set is available. Through the data set, we can apply some statistics and machine learning algorithms, and we can find out some new description of data, and we can modeling of data and do further business analytics. So that is what actually it is where we data science and AI intersected, decision making and describe it as intersected in data science and also in AI. And we can go for the modeling. That is, you can go for statistical modeling. Two types of modeling is there: statistical modeling and algorithmic modeling, right? So we can go for algorithmic modeling. Then we can use in data science and normal regression analysis. We know that linear regression and logistic we can apply it here in modeling itself, and we can understand about different kind of charts about that particular data set, how it is looking like, how the variety and variance and data deviation, all description we need to understand it through the diagrams. We need understanding through the modeling of data science. So here we need to understand about what deviation is here completely, what represent AI and what represent data science, right? And you know that, right? So this is a very important slide. So on this slide and next slide, we need to understand whole scenario of how the AI will be evolving, right? So we need to connect billion of entities. What is IoT? IoT, everybody is saying billion of devices are connected. But real time, we are not understanding how the billion of devices are connected. So in minimum, we have to do a simple project is like our mobile phone with some TV we can work, and then we can any home appliances we can connect with our mobile phone, and we can control through that machine, right? Through the IP address, we can know that, right? So here, how we can connect, for example, a telecom network. Telecom network, it is connected 100 crore people in India. Everybody is having mobile phones, right? So you can remove some age groups of people and child, then everybody is having mobile phones. How we can connect all the people is a telecom. So how the customers, right? The passengers, all are customers for airline, right? How the people will connected, what facilities, and how the sensors are, how many sensor entities are there, how many devices are there, how all the devices are connected, and trillion of distributed interactions, right? And hundreds of interdependent metrics, and millions of real-time decision every day, and hundreds of workflows are there for we are understanding how that mapping it has happened after interaction, right? You can see that billion and trillion and hundred and million and hundred of workflows. So we need to understand these whole scenarios, right? If you go for any one business, we need to understand that business, how many, then we can mapping into different area. For example, in telecom industry, you can take all people, right? What people will do, right? So that trillion of distributed transaction will happen, and how hundreds of interdependent metrics will be calculated through the particular telecom industry, how the real-time decision will be taken for every day, and what workflows are happen for each and every customer perspective. So this all are entire thing will happen through this particular telecom industry domain itself, right? So we can see here, it's a very interesting, and we can understand about this whole diagram, it is like layers of AI. So we need to understand 8 layers of AI. How we can define AI? It is a software agent or hardware agent. Software agent or hardware agent shows it is like intelligence or the mimic action of the human. So we need to understand here. So first we need to understand layers of AI, how we can understand the layers. Digitization is in one particular first layer, and interpretation and causality and cause and effect is a third layer, and fourth layer is a prediction and effect and cause, and fifth layer is an explainable layer and controllability layer, simulation layer, optimization layer, and adaptation and readaptation layer. First, we need to understand for all layers. First, we need to know that digitization layer, it is like we can convert it to physical data into digital data, archive to physical. So we need to understand about digital layer. Nowadays, we have to know that everything is a digital, right? Next, we move on to the interpretation. Interpretation layer is how we can interpret into one data into the different forms. Like, for example, assigns a high level semantics to low level data, speech to text, face to emotion, video to action. This is our high level semantics to low level data. Multiple interpretations for one input possible. So like multiple interpretation is means what actually I can speak, right? So you can generate text and speaker name, and you can generate gender of the speaker, what age group of the speaker, and what emotion of the speaker, right? These all are multiple interpretation for one input possible, right? And many to one and invariance learning. That is what we can say as invariance learning. We can take an image, right? If you see the image, what is the scale of the image, what are the attributes of the image, and how we can translate illusion, and then what goes of the image. These all are many to one. You can see that image, some image you can capture in the mountain, right? You can see which place the mountain is located and how many big trees are available in the mountain, and we can see any temples in the mountain or any animals in the mountain. So we can see in the each and everything, it is in many to one, it is representing as an image. So how we can convert into one particular semantics to the low level data as well as multiple interpretation, all are interpretation. Interpretation is which thing it is most important to understand, right? And if you see a third layer of an AI, causality, that is the most important thing, cause and effect. You should understand about cause and effect. In the world, all the actions are happened through cause and effect. Something happened and what is an effect, right? So what and cause and effect we can understand here. So if any accident is happened, what is the prevention of the accident? That is a cause and effect. That is the cause and effect. That is in causality. Right? Yes. And fourth layer of AI is in prediction and effect and cause. Right? Previously, we need to understand cause and effect. Right? And fourth one is an effect and cause. So what is the difference? So we need to understand about. So if in the case anything it doesn't happen, right? We can go for this. For all machine learning algorithms, the prediction, right? The prediction we need to understand about effect and cause. So effect and cause, we can see a lot of applications here. Prediction, part failure prediction, the mechanism, right? In industry. And critical alarm prediction, car failure prediction, critical health event prediction, and chance prediction. These all are effect and cause, right? For example, somebody has installed Ola app, right? And 1 week after they uninstall an Ola app and installing another Uber app, then they can book through Uber, right? Why the customer it is changed from that Ola having several reasons. What happens in effect? Because something happened, that is what actually happened, right? So this is what the prediction approach. And any causes happened, and then we can take it for the effect, right? and we can we can see in some prediction, we can for the recommendation like media recommendation, product recommendation, search, personalization of ads for the products, companion personalization, art personalization, homepage personalization. All of it is coming for this particular two layers. And we can see about a fifth one is explainable AI. So explainable AI, it isn't any action it has happened that, so we can explain correctly for which why that action it has happened, what is an effect. For example, in house and price, we can say that the particular area, the house price will be there after 6 months, after 1 year, the price will be increasing. Then we can say why this price is increasing. Then we can say the correct explanation, right? Same and different understanding of explanation. Then that particular rail will taking away. So for a simple example, I'm telling for the house and price, and we can go for the controllability. It is an one layer. So what are the parameters we need to control, and how we can do it mapping into predictions. For example, you can consider in different attributes, which attributes are controllable, which attributes are not controllable. For example, you can throw a ball in the air, which things we need to control, that attributes we can take, which things we are not able to control. Mass we are not able to control, right? And wind direction we are not able to control, right? So we can take an attributes, that particular thing, which particular thing it is an observable in the input, and controllable, which things we are not able to controllable. For example, you have to go for the healthcare prediction, which things is we have to control. The patient is having blood sugar, right? The patient is having some other lucky habits also. He is drinking, he is smoking, right? We are not able to control these things. We can say that how we can control these things, and which parameters we can control through this particular patient, right? Controllability also very important for understanding for the predictions, and how we can simulate it. So how we can control the variable? If it is in control, what is the benefit? How we can understand the simulation? We can go into the deep simulation also. If you take any one chance prediction, if you take for that, so how we can simulate the chance prediction in simulation through softwares, and we can understand which things we need to control, and how we can improve that chance prediction method, right? So the customers will be staying in the same company. It is not going to out of the company. So what things I need to control, how I can optimize through the best parameters I can given for my input, some optimized way I can use some algorithms here, and how I can every time input changes, and how I can go on re-optimization. That input it is won't work, how I can go for the re-optimization. So now we can see here overall AI, it will be coming under this one. So we are talking about AI ethics. We are talking about AI explainable AI. We are talking about AI controllability. We are talking about AI simulation. We're talking about optimization of an AI, how we can do through deep learning algorithms, how we can map it to the neural networks, right? Different inputs we can give and train the neural network, and then we can make into the better model. And we can re-optimize optimization of AI, and we can use it, and we can understanding of so given the solution for the problem, right? I cannot take any one problem statement. I am not telling you about that particular problem statement to each and every layer. I can tell you general procedures of what we are understanding about AI layers. I think so everybody will understand about layers of AI. If you learn this AI, everybody this understand this all layers about AI. And you can come for the machine learning. Machine learning is how do we make machines to learn from data, right? And we need to understand machine learning. It is a program, right? The learning program, right? You can take one learning program. The learning program will learn the data, or that learning program will learn the data. How to learn the data for a task, right? I can given a task to the learning program, right? Different tasks I can given to the learning program. So the learning program will understand different tasks, and the learning program will show the performance, right? Performance, how I can do that? Through accuracy, right? And through error rate. So I need to understand that I can give different tasks. Task is nothing but classification task I can give, clustering task I can give, denoising task I can give, right? And machine translation task I can give. Any task I can give to the machine. That algorithm will taking a task, right? Task, and then the algorithm will show performance, right? Based on the performance, I can measure in the experience of an algorithm. Performance it is getting lower, then I can improve the performance. That I can add a lot of improvement of the performance, right? That based on that re-optimization, that is what I'm telling you. Re-optimize the performance, right? I can get some experience, right? How it is now and how after that re-optimization it has happens, how it is improvising of the performance and experience. So this is what we need to understand of algorithm, right? I can first show you that machine learning, it is a computer program is set to learn from experience E with respect to some classes of tasks and performance measures P. The performance of task T performed by T improves the experience. That is what I'm telling you, right? Learn from experience T with respect to some class of task T and the performance measure is P. Right? We need to understand what is E, what is T, and what is P. That is the most important thing. So normally, what is T? Right? Classification task. Right? I am not talking about the learning function of the classification. You can understand the decision tree classification. You can understand that entropy theory, information theory. That we are not coming to that particular part. We're talking about classification. Classification is one kind of task. Right? We can classify the different objects based on the subject. Right? So if it is classification with missing inputs, like it is a cluster. It's a cluster. And regression. Regression is nothing but to learn a function, right? It isn't that function, it is called a line function or sigmoid function or polynomial function. So which particular function? Regression is like a prediction problem, right? So, right, we can go and find something or we can predict something. Right? Both the two tasks also the prediction problem, a regression problem, and transcription, machine translation, and structured output, all are the tasks. Anomaly detection, de-noising, and density estimation. Is all are the tasks. And we can go on to the performance measure. That is a T. That is a T, and we can go for the performance measure as a P. P is nothing but an accuracy. How we define accuracy? The proposition of examples of which the model produces the correct output. We have a data set, right? I can give a data set. All of you know that. We need to understand here for the machine learning. If we have a data set, we know that we know two things: training and testing. Right? We know the two things. Training and testing. The training is the model is trained using the training set. The performance is assessed using the test set. Right? So if you train the model, right? If you train the model, so like we need to understand about the training is properly happened or not. How we can understand what is the bias and what is the variance, underfitting or overfitting of the model. Right? How we can adjust in the training data set. Right? So based on the data set, the performance will be checking through the test set. Right? The performance, the training set properly trained, that performance we can go on the test set. Right? So this is what we need to understand in the performance measure, accuracy and error rate. Right? Here model, which particular model we are using that applying to the data set, that the data set giving the correct output. I can take different models. I can use for SVM model or decision tree model or KNN model, or any model I can use and produces the correct output for the proposition what is an accuracy of it to finding the particular class. And we can go for the deciding the performance measure is not always a very straightforward method, right? We can go for the regression task. Sometimes you can go for the regression task. Should we penalize the system more if frequently make medium-sized mistakes? something it has happened, that mistakes will happen rarely, right? This is also happened for the performance measures, finding the performance measure. And you can see here, and we can move on to that, and we can go for that. Wait a minute. So we can go for right. So we can go for the overall entire understanding of this particular machine learning and what are the phases of machine learning it is available here. So supervised, unsupervised learning, and you heard about this all the names earlierly, and ensemble learning and artificial neural network, and you can go for the reinforcement learning. All algorithms names actually mentioned in this particular slide. If you understanding about unsupervised learning, right, dimensional reduction visualization and clustering, a lot of algorithms are available, right? Fuzzy k-means, DB scan, and mean shift, and you can go for supervised regression is there, and linear regression, polynomial, lesser regression, and classification. You can see different classification algorithms also there, and you can go for ensemble, and you can understand about AN and CNN autoencoders, and RNN, recurrent neural network, multi-layer perceptron. So these all are entire algorithmic understanding of this particular domain in AI. Right, and you can move on to that. So you need to understand here how the AI will be going for the society. For example, if you take we learn about AI, we are talking about data science, we're talking about machine learning, right? So what do you understand about the future of education? Future of education nowadays, the education will be, now it is increasing growth, right? So a lot of things will be available to the students. That is, internet is there, right? Students who nowadays wants to learn through everything through internet, so that isn't always available, and we can provide that information highly personalization to the students, right? So that isn't available, as well as we can give for the highly personalized environment to the students. How we can provide through the internet? So internet is like a library, and we need to understand about in future MOOCs are the new classrooms. Teaching machine will be the new tutors. Tablets and VR technologies will be the new schools. That is the future of education, and we need to understand here MOOC courses. You all know that NEP is giving you 60% of courses are in classrooms, and 40% courses are we can through going for the MOOC, right? And project-based learning, online-based learning, a lot of things will be there in national education policy. So in 2040, 45, right, as per the education policy, our complete education it is a multidisciplinary. So we need to learn all the areas, and we need to create multiple different types of curriculums and syllabus that we need to provide through online. That is like NPTEL and SWAYAM courses, right? So this is the future of education, right? We need to understand the concepts. The concepts will be understanding through images or through videos or some simulation. The properties we need to understand about in depth through virtual reality and how the world look like. Everything is like in new schools. So I hear about that in UK. Some of the universities they have to started that teacherless classrooms they have created already. You can go and search in internet. There's a lot of things and available in internet itself. You can go and find the university name and then how they are offering that teacherless classrooms through AI, right? And previously I mentioned that the three types of AI is there. One is artificial narrow intelligence. It is like a small device. It is connected to some software. That device, right? will be talking about talk to that particular software, then the device will be capturing some information and given to you. That is an voice support or text support. Already we know Alexa, it is a best brand. Already everybody knows that voice supported that. You can speak to something in Alexa. Alexa will convert it to speech to text. That Alexa will be talking to some device and then Alexa will be coming back to the result. That is a weak AI, right? That is a weak AI. So that involves only applying AI to the specific task, right? And you can go for the general intelligence. That is what I'm saying. We are now in the phase of general intelligence. That is, in strong AI involves mission that possesses the ability to perform any intellectual task like a human does. That is what the phase we are now. We are here, right? It is not surpassing a human. It is now we are competing with a human, and that is a surface intelligence. That is a ability will surpass humans. That is a super intelligence. In another 10 to 15 years, it is not man that is required. Everything will be doing in missionaries itself. And this is a AI with human performance. We'll see that. So you can understand narrow AI and general AI and surpassing of AI and human, smarter than human. You see here in 2000 to 2020, how the AI way understanding of each and everything. What is the problem here and what already AI it is done. So you can go into that top 0 human performance benchmark, and AI system will perform better than humans, or AI system perform worse than humans, right? Something it is there, handwritten recognition. It is a still it is an open area. We can work for the research and reading comprehension, understanding of language, image recognition, speech recognition, right? All we need to understand, right? The narrow intelligence we can see here, right? And we can give for the task and then we can do that and operate at the human level, right? It is smarter than human level, it isn't surpassing level. So now we are in 2024 and 2040, 2045, they will be surpassing of human. And you need to understand here, if you go for any model, right, you can understand the deep learning. So this is the all 6 jars we need to understand here. Data and what task we have to do that, and what model we can apply, and how the model will be providing loss, how the model will learn, how we can evaluate the model to accuracy. So this is what any model we can fit into the machine learning or deep learning algorithms. We have a data set, perform one task, and create one generate one model, right? We can go for MP neuron model, or you can go for perceptron model, multi-layer perceptron model you can generate, or you can go for the neural network approach, right? You can go for CNN, RNN, any approach we can take, right? Through the approach, and we can have understanding about different models. For example, you can take a sigmoid model, and you can go for the S-curve, one formula it is available, how that model will learn and how that model will be produce the loss. What is the formula for the loss? What is a model formula? And what is the learning algorithm? So learning it is an algorithm, and loss is a formula, model is the formula. You can apply learning algorithm to loss and model formula, and we can evaluate it for a certain task in the data. That is called a deep learning. Deep learning, it is all 6 jars we can do that. Deep learning is nothing but a huge data with very complex relationship. It is required. We need a complex ML function. Models are required. A complex formula is required to solve that particular problem. All right. And in education, we can understand about these are the scenarios. We need to understand the scenarios here, right? For example, if any student is writing examination, each and every step it is a data point we can generate, and we can understand about the handed recognition and what kind of answers the student will be writing, which is the correct answers or not a correct answers. Each student writing exam or each word or each pattern, we can understand about that ability of the student writing practice. That is also we need to understand here. For example, somebody is typing in the Google, right? The Google every day is searching. It is taking each keyword is a searching. Then how many keywords the Google will be taking into the queries? How many queries will be taken, right? So these all are the scenarios we need to understand. It's a large amount of data and how it is offered to the education. And these are the main applications of AI. We need to understand AI in biometrics, right? What is the challenge in biometrics in AI? 850 million people globally lack legal identification. And according to that World Economic Forum 2023 in June, how we can apply into that, how we can go for the biometrics, computer vision, cryptographic, security, communication, trustworthy AI driven identity frameworks. All are this, like we need to understand AI in biometrics, and we can go for AI information security. So the cost of fake news estimated as a billion of 78 billion problem annually. So how we can go for this? What areas we are working in interdisciplinary and innovative research through this particular challenge in AI and information security. So open-ended problems. AI in cybersecurity. Cybercrime will cost the global economy more than 20 trillion by 2026, right? And you can go for AI in transportation, and through trillion transport infrastructure investments are needed globally each year until 2040, right? In transportation, how we can apply AI techniques, right? And what are the interdisciplinary approaches happened in this open problem challenges in transportation, as well as for AI and robotics, increased need for safe and trustworthy autonomous behavior. This is also most important legally, how we can generate autonomous vehicles. That is a huge research nowadays. And AI in food technology, right? 13.8 million households were food insecure at same sometime in 2020. And AI in medicine. So it happens, diagnostic errors affect 5% of adults in the US each year, contributing to approximately 10% of death. Right? How we can predict these things? So we need a lot of multidisciplinary approaches required. And material science also, how we can find materials. In the world, everything is made of materials. So how we can create a general stable materials in a challenge. AI models discover more than 2.2 billion hypothetical materials, which are stable materials also. And we need to understand is completely AI as a service, building blocks for all our AI needs. We can take different areas and apply to different domains. So we can, that is what actually I can show in the diagram. It is like AI as a service. We can take which particular domain refineries we can take, and then we can find the beneficiaries of refineries and what are the application we need to develop and which services we can add and which particular service is required for AI services and who are the producers. So it is what that infrastructure it is goes, right? We can use different capability of AI subdomains. We can use it. Each domain, health, education, transportation, each domain we can take it here. And we can talk about generative AI. So I think so last session you people learned about generative AI, right? And then I can show you, right, how we can generate AI and LLM, and then so this all 10 steps how we can generate adaptive content generation and progressive skill development. These all are coming under personalized learning pathways. So generative AI can how it will personalize learning resources based on the faculty content current knowledge level, helping them understand quantum computing fundamentals, case concepts, and advanced topics. And real-time question answer systems. And these all are generative AI content. Third one is customized course material creation. Fourth one is code creation and programming assistance. And these all are generative AIs and benefits, how we can understand here. Collaborative research and paper writing, and dynamic workshops and training simulation. Is each and everything we can use in AI, right? And assessment and feedback and resource aggregation, and this is risk identification simulation. This all are let's see here. right? This thing already the last session you have seen in this OpenAI and GenAI and Perplexity. These are all generative AI based popular tools. Then we can LLM models. We can move on to this, and we can work. A lot of AI tools are also available. Right? So you can go and search in internet AI tools in education, or AI tools for some speech, or AI tools for vision. A lot of tools are available. If you want to generate arts, AI tools are available. Anything, a lot of tools are available in real time. You can have a tool, and free tools are there, and otherwise you can go and some pricing also there. You can go and opt for the pricing model, and then you can work with particular application without installing any softwares and all. So you can make your own application development, right? And you know that you can go and prompt, and then a chat GPT prompt, and then you can write different kind of writings also possible in it, right? You can go and type suggest and blog post like ideas of primary keyword. You can type in any one Gen AI technology for any colleges and universities. You can type and see that, and you can write a 60-second YouTube script also through ICSS, how is using pandemic disaster management approaches. If you create a link checklist, all are chat GPT, you can go and give it. Chat GPT will be giving your result to you, back to you. And programming also, if you write any algorithm, encryption or decryption, or can want to write a database story, if you want to generate queries using ChatGPT, also available through the generative AI, right? And finally, I can move on to that 5 to 10 minutes. And already it is 9:15. So now I can move on to the types of quantum computers. So first thing I want to say about it, what is quantum machine learning? We're talking about machine learning, right? What is quantum machine learning? So a lot of simple taking task, 1,000 tasks or 10,000 tasks, we can have a different task, right? And then we can combine together, right? Given a result. How we can do that? Are the same two tasks are happen this two places and executing in the same thing? How it is possible? I say yes. A person sitting in this one classroom, also sitting in another one classroom, both dually sitting in two classrooms and listening to lectures. How it is possible? Right? Entanglement. So how understanding of entanglement, and how we understanding about the superpositions, right? This is talking about quantum. So quantum, if you want to read entire books in library, it is a one single shift. It is a quantum, right? Each page of the book, it is an each task want to read, or you can have a concept of the particular book into 400 pages, 500 pages. We can take into a seconds. We can understand entire book content, right? How many superpositions are required there? So here we cannot talking about classical bits, we can talking about qubits, right? So qubits we can talking about 0 and 1, right? 2 qubit you can take it, and 0 0 0 1 1 0 1 1. So combination we can take, and 3 qubit, 4 qubit, and combinations we can take. Each combination is doing a different task, right? We can combine together all different tasks, and then we can make it the simple and a single result. So quantum we can apply, but it is a different thing. It is a quantum. We need to understand here quantum mechanics. That is most important concept we need to understand in mechanics, as well as quantum classical algorithm, Shor algorithm or Graver algorithm. These are classical algorithms in quantum. So we need to understand the basic classical algorithm. It is, for example, Shor algorithm. We need to understand the prime factors, right? How it is we are finding for the prime factorization. So this all it is coming under quantum. So higher, how we can integrate with quantum learning, right? Machine learning we are understanding now the different phase. How we are understanding it is in quantum. Quantum it is like completely understanding of gates of the quantum. It is first mandatory thing. What are the gates are available in quantum? Each and every gate functionality mathematically you need to understand the logics. Now you can see types of quantum computers. Four quantum computers are there: superconducting and trap and photonic and topological quantum computers. So now what we are learning now, supercomputing quantum computers. For example, if somebody is providing quantum, CDAC is providing quantum in Bangalore. Which quantum computing? Superconducting quantum computing. Somebody, if you take for an IBM, superconducting quantum computing. Somebody, any other industry, if you take in Mumbai, any other industries, maybe provide in quantum computers. So how the photons are involved in the quantums, and then how we can make in the quantum machines. Quantum machines are very big machines, are very cost effective. We are not able to set up a lab. And classical algorithms we can use like as a quantum. And when you understand about that thing and how the quantum science are mapped and how the quantum AI, yeah, that is what I want to talk about. So that is the qubits I'm talking, and fundamental thing. It's not a single day we can cover all the things. What are the gates in example Pauli X and Y, Z? Adamant. A lot of gates are available. We need to understand the functionality of the gates and how the quantum computing machine learning will be working here. So we can understand in this how normal traditional reflect machine learning will do and how quantum computers will take a decision as like as a car. If you use quantums, a lot of error will be happening because of we are making for the qubits, and qubits are like 2 to the power. That much of task will be generated. A lot of tasks having a lot of errors. How we can go for controlling error mechanisms also. We can move on to the separate topic. We need to study about the quantum. That algorithms also there. That is what I'm talking about. Prime factoring algorithm and how quantum computing, machine learning, and AI will be parting up this all applications like autonomous vehicle, drug design and material design, financial modeling, and chemistry formulation of molecules and big data. All are it is coming here. And classical computing algorithm is how we can make one quantum neural network. Like input layer and output layer, it is in between, it is a hidden layers are available. How we can go for the quantum neural. So these things we can talk more than more. And what are the classical algorithms in quantum, how we can make. So typically we can design a neural network. Instead of that, we can go into that neural network phase with a lot of quantum gates. Each quantum gate is having separate functionality. Through the functionality, we can explore the same machine learning algorithm into quantum. For example, we can see, I can show you. Quantum support vector mission. Classical SVM and quantum SVM, how it will be happened. That is what we need to understand in quantum AI. So all the tasks, how we can give into that. Here we can understand about quantum support vector mission. So classical SVM and quantum SVM, right? How what is the difference? You can see for classical SVM, order of n qubit is required in time, but quantum it will take order of log n. Very few comparative, very less time it is required for the classical SVM. And each and everything, data encoding, hardware, and data processing, right? But requires a quantum hardware. But here, classical computers, what we are having in our laptop, also we can run. Our GPU support, it is there, it is better, right? And you can see quantum. That is what I'm saying. If we implement anything is quantum, we can design a circuit and we can make as a quantum. It is completely, it is a classical as well as for the quantum. So we can understand here. And the quantum K-means cluster. So this all are optimization algorithm, how we can use normal into quantum, how we can understand the quantum versions, right? And so this is today is my lecture. So I think so. Last 15 to 20 minutes, I can go through the slides. But even though it is a very hot topic to talk about quantum, it will be taking more time to explain each and every keyword and every conceptual thing. But here I can give overview of this particular thing. What we are doing included.
Yeah, participants, do you have any questions? Yeah, I think nobody has any questions, sir. Uh, So I extend my deepest gratitude to Dr. Soundarajan S., Chairperson of the Department of Computer Science and Engineering at Amrita Vishwa Vidyapeetham, Chennai, for delivering an illuminating talk on future trends and societal consequences of emerging AI technologies. Your insightful discourse shed light on the transformative impact of AI on society, offering profound perspectives on both its potential and ethical implications. We sincerely appreciate your time, expertise, and thought provoking insights that have enriched our understanding of this ever evolving domain. Thank you so much, sir, for your beautiful talk on AI. So, dear participants, as we come to the close of this enriching session, I extend my heartfelt gratitude to each one of you for your active participation and engagement. Your enthusiasm and insightful interaction have truly made this session a success. A special thanks to our esteemed speakers, Dr. S. Soundarajan and Dr. Vijay Lakshmi P., for sharing their invaluable expertise and thought provoking insights. It has been a privilege to learn from such distinguished academicians and researchers. Thank you once again for both of you. Tomorrow, we would all meet again online at sharp 6 p.m. for two more sessions by Dr. E. Suganya from SSN College of Engineering, Chennai, and Dr. Subhash Nair from Bosch, Bangalore. For your reference, the session recordings as well as the resource materials both would be shared by tomorrow morning in the WhatsApp group. So please keep an eye on your email or on the designated platform for your access. We appreciate your time and commitment to continuous learning, and we look forward to your participation in future sessions. Thank you once again, dear all, and have a wonderful evening. Good night.
Thank you, ma'am.
Thank you,
I can
sir.
leave now, ma'am.
Yes, sir, you can leave. Thank you, sir.